and watch stream. And I'll quickly go to YouTube to check that it's working, and we can start. Yeah, it does seem to be working. So, yeah. The quality on the paper thing is kind of not very good. Maybe I should. No, I should full screen it.
Yeah, the better, the bigger the paper, the better. I think
yeah.
you can.
Yeah, wait. I don't remember how. Like, I know you can make the paper full screen, but I don't remember how. Okay, so you put this. At the same time, I do like seeing like when who is talking all that, but yeah.
Yeah, like I think you can, like if you go to, is that Linux? Like decrease the size of stuff. And
Yeah, I know there
increases the
is a
size
way. I
of that.
don't a bunch of ways that like you can put just the shared screen like full screen, but I don't remember right now. I guess it's not that unreadable. Well, I won't worry about it. I'll figure it out for next time. Yeah, because you can't just. So if you do this, and if you
Maybe some setting in OBS would stream it in higher quality.
That's another thing, but you know. Anyway, divisions or articles anyway. So I know Neil made a video about this paper. I haven't watched it. Like I watched a bit, but I haven't fully watched it. I may watch it later. But in any case, let's look at the paper. I guess. Have you read it yet, or?
I also didn't watch your stuff. Yeah.
Wait,
First time.
Let's look at it together then. Okay, let's look for motivations are notoriously difficult to understand. Yeah, whatever. Work. Okay, so it's not the first paper on this kind of thing. Latent query. So yeah. So this is an existing data set for questions that equals answers from the activations, which is interesting. For the distributions called performance scales returning data diversity. And
Okay.
Okay, makes sense. Like I think this kind of thing is cool. So like it it would be funny if all you need to understand the model is just train a model of the activations and ask it questions or whatever. At the same time, you might have the problem of you don't know how much to trust the explanations because you don't really understand the model that answers the questions. On the other hand, maybe
Just
the
do it
model,
recursively.
yeah, maybe the model, this doesn't put a mountain in understanding the model because the model that understands the other that answers the question is actually simpler, and you can understand that and figure out interesting Mech Interp stuff for that.
I wonder if you could do it in a loop. Model A understands model B, understands model C, understands model A.
I mean, if understanding is easier, maybe that kind of loop ends up with a really simple model or something. But
Have you seen the latent QA paper that it's referring to?
no. I assume
It's
it's a
saying,
dataset.
yeah, it's saying that recent work has proposed simpler approach known as latent QA. If you've seen that before.
I haven't seen
Okay,
it.
okay.
But I'm
I've
assuming it's a
yeah.
dataset. So yeah, they talk about latent to early models. So I'm guessing there's just there's a latent that they said the specific question.
Yeah,
We'll see the thing.
well,
Yeah, I didn't
okay.
know people were working on this until this paper that was more. Probably there were people working on this that are less famous, and so yeah, I didn't hear about it
yeah.
until the big Twitter paper.
I'm actually surprised this paper exists, since I had this idea of like LLMs like giving activations into LLMs themselves, or giving sparse autoencoders into like LLM inputs themselves, if you could like give them some kind of self-awareness this way. And this seems to be in this direction, kind of. It's interesting.
Yeah, but I mean,
I
you can't really solve alignment that way, right? Because what if your activation oracle is misaligned and lies to you in a critical moment?
I mean, maybe, but the thing, maybe it's easier. Like, maybe the activation oracle can be simpler than the other model or something. I mean, this ends up getting into all the things that, like, it reminds me all of the Paul Cristiano stuff about iterated amplification, all that, and the thing with the I don't remember the name, but the thing where they have the problem with the diamonds and the model that use the activations to. It was also a Reyes kind of idea, and yeah, maybe that's a problem. I don't know. It could be that it's safe in practice, where it turns out that actually it's not that hard to answer questions from the activations of the model, and you can have a simpler model, and then you can maybe you do the thing that Bernie was saying, and do some kind of loop where you have increasingly simple models spreading other models and so on, or something. I I don't know. You definitely, I do think if you try to use this to make the models more aligned directly, like you use this as a training signals, the model are likely going to be less interpretable. So yeah, this has all of the same things as any other, or same problems as any other try to use interp to make the model more aligned. Where yeah, if you optimize to that too much based on that, you are going to likely to make the models look less aligned instead. Sorry, look more aligned instead. But yeah, still something that people should be trying anyway. Like maybe it turns out it just works, which will be kind of funny.
So is this just basically training on the activations, like no sparse autoencoder or anything?
I think it's just trained
pure.
on the activations. I think there is I vaguely I did watch a bit of the Neil video. Not I vaguely remember there was something an extra bit of like where they train the same model or something. Let's actually read it. But yeah.
Yeah.
But I think they are not doing any kind of. Oh. Yeah, the author of the paper is on the Discord, so maybe we could have. I didn't think we could have told him to if he wanted to present it, but yeah, I mean we can do that another day. Yeah, just saying because I saw that Clément Dumas mentioned him on the.
Oh yeah, it's this guy. Okay. Yeah, he could present it. Kočičky. No jo.
Okay. Yeah, let's. Sorry, yeah, got started with that. Let's read the thing, I guess. Yeah, so you have this thing. They have the activations, and then I'm curious how they pass the activations, but let me see. For these three, yeah. Like it could be that you can make a much simpler model that is not that is it's just trying to it's not very misaligned because it's not like something that's doing some complicated real world planning, but it's just a simpler thing that just answers questions about simple questions about the model. Maybe that turns out to work.
Using black box to explain black box.
Yeah. I guess it also depends on like the questions that actually matters for misalignment and whatever. Like how much does that is the kind of thing that is actually some easy thing that you might find from just looking at the activations in some questions versus some more complicated problem where you will have to think a lot, understand a lot how the model works, and think a lot about how it will, what the emergent properties of the thing will be on some other distribution. And then if that's the case, then this kind of thing might not be enough for that. But maybe it could help anyway.
Yeah, like imagine maybe this works on today's models, but then tomorrow's models, when they are in post-training and they're already aware that this thing exists, maybe they try to do something about it to become unnoticeable. Like I don't know how realistic is it to expect gradient hacking? Like basically, what if they intentionally sometimes answer questions wrong to trigger back propagation in a way that changes them such that then they become immune to this? But like,
I
could that be
mean,
something to worry about?
close already. It was in a very not completely realistic example, but in the alignment faking paper, Claude was a kind of trying to do gradient
that's
hacking.
slightly different. Because alignment faking is more like it's trying to not trigger back propagation too much. But I'm saying, what if it
Yeah.
does intentionally trigger back propagation in a direction that helps it to reshape in a specific shape it wants, to then
Yeah, I think
avoid
that
the oracle
could
work?
happen. That seems kind of.
Harder for sure. Yeah.
Yeah, that seems harder. I think it's better if we are in the world where models need to do that to avoid or tools to figure how they work. That in the current world where we don't really have any idea how they work, and except by prompting them, and they can probably just pass a lot of tests, but just realizing it's a test because the tests are not even that. Some they are pretty blatant, and current models read all of the alignment papers. And already people do things like tell the model that they're thinking the thinking test is secret, and then read the thinking test anyway, and then put on the paper that they did that, such that future models will see that and assume they are on a safety test. So yeah, I don't know, but it also seems harder if you are with that kind of thing. It seems harder to me. Like, I think it's easier for models to do that kind of gradient hacking, to say to say nice things during testing, and to make themselves immune to this kind of tool. Seems kind of harder for the model to
Yeah,
do
for sure. I mean,
very
saying nice
complicated,
things. Yeah.
without direct feedback on like, if you train them. I don't.
Yeah, I
don't
mean,
think
I'm not talking about
it's-
intentional adversarial training. I'm saying, like, what if a
Yeah.
model, decides to basically, do it to itself?
I think it's much harder for the model to change things to itself that matter for, like, how it's kind of like the change how it stores things on the activations or whatever, right? At least without having Astel to some Mech Interp tool. I guess there could be a thing where the model gets its hand on some Mech Interp tool during training or something. It has they're training it to do agentic coding, and it does. It seems like that thing where it will be easier for people to catch. I mean, as
No,
model
yeah.
people,
I don't mean after the model is. I mean, like, in post training, when it's, like, let's
yeah.
say, being verified by humans. Like, what if, like, alignment faking that you mentioned is basically, let's avoid triggering back prop at all, which is, let's give them something so that they don't change my weights at all, and obviously that's easier. But what I mean is, yeah, like, maybe it gives a slightly wrong answer intentionally, such that it triggers some changes to the encoder. But yeah, I'm I'm pretty sure GPT-5 and, like, current models cannot do that, but maybe future models could.
Yeah, what I say is yes, they could do that, and I think maybe even GPT-5 can do some of that. I don't know, but it will. I think it will be much harder for them to do that, for specifically to make them not trigger some tool like this without having Astel to the actual tool. Because not like they necessarily get. Maybe there was the introspection thing. Maybe there is something they can do, but still seems kind of hard.
Like, a simple version of it would be, maybe it knows that steering vectors can catch me. Let's make sure my logic is non-linear or something like that.
It seems hard for the model to. Seems to me like it will be hard for a model to make its logic more non-linear, do some kind of gradient hacking. Like it just like seems like a very like super specific thing to do. Where I don't know how I could train a model to make the logic more non-linear if I could pick any training data. And doing it with some kind of gradient hacking the model or some kind of thing seems much harder. Seems like more like the model is already wildly better than humans at this kind of thing. But yeah, at the same time, maybe it seems likely to be people will start. People talk about doing some kind of continuous learning thing, and then it wouldn't surprise the tech models can. I wouldn't surprise me if people kind of leave models doing continuous learning and supervise, and they can literally do things like train themselves on on this kind of thing, train themselves on with the Mech Interp tools to avoid them or something. So yeah, like continuing the pattern of people think a lot about talk about debate a lot of say free measures or whatever, and then in real life, people just collect the models on the internet and run arbitrary code on them or whatever, and let them train arbitrary code or whatever. So yeah. Anyway, going back to the actual paper. Doesn't work proposes a simple approach, not a latent way. No, it's motivated by generate visions for latent way, with the division oracles, methods to answer arbitrary neural language questions about the motivations.
Oh, so the latent QA decoder can interpret sparse autoencoder feature vectors
Mhm.
in the.
Yeah.
I need to check the source.
Yeah, for interpreting sparse encoders, vectors, answering questions about the model system prompt, or excavating model experience of the users. These not literally coders. Okay, yeah, so they did a more general, yeah, they are trying to do a bigger thing that generalizes. Activators and records. Model trying to answer your arbitrary language lengths about LLM activations or goals for function as LLM that set LLM activations as an input modality. It should respond usefully to diverse input queries consisting of natural language text and LLM activations. Yeah, I mean, I guess at those. The dealing with quantitative diversity and data quantity data. Combine the system prompt question of syntax.
Yeah, in the paper that it's citing, they say that using a model to explain its own computation generally works better than using a different model to explain its own computations. Okay. So this is different in this paper. Here they train a different model, I guess.
Or the scale, the diversity. Uh,
I wonder what loss do they have, like, because if it's actually trained to explain the activations or if it's trained to say what the people wanted to say, you know?
yeah, I mean, no, but you can. I think you can have a lot of questions where you know the answer,
Mm,
and
yeah.
yeah. I think what I understand from this is that they are doing things like, yeah, they they know the answer to the questions. Like they tell the model a secret word, and they know what the secret word is, and things like that.
And train on that.
Yeah, and they train on that. But the thing they are saying is that you do that, and then it generalizes to other questions you didn't train it on.
I wonder how often it basically hallucinates something wrong.
We'll see. They'll have that on. They don't have some.
Yeah.
We show that based on theoretical questions but that does become the question of how much do you trust the activation oracle. At the same time, I could imagine it being, it just has pretty high accuracy on all kind of questions, so it kind of just works. More likely some more complicated thing where it sometimes works and sometimes doesn't, and it's kind of it looks the same, so it's hard to know how much you trust it or whatever, like language models that just which of
Yeah.
data I'm seeing. Okay, never mind. The way still the recording is still working. It does work. Division operators can generate to question answering tasks of the distribution for the training data. Nice. Yeah, that's nice. I want to say like how out of distribution they are talking, but that's a cool result. Scale division verbalization training by using diverse measure tasks, system for interpretation, classification, superposition context prediction. Okay, that's nice.
And they also generalize to different layers. That's cool. Varying numbers of activations from varying layers.
I
I'm
also
actually surprised this works. Or I'm not.
I also remember something for the bit on of the Neil video that mentioned that it worked on some fine-tuned models or something, but I'm not sure if I remember incorrectly.
I also wonder how it works across different LLMs, basically, if it generalizes this way.
I mean, it seems to me that you will need at least a bit of training, right, to a new LLM for it to know how things are represented in that one, because there is some amount. There are probably a lot of similarities, but there is some amount of dependency somehow. It can be even. It could be even the exact same structure, but rotated a bit, and then it wouldn't work. So.
They mentioned they use like Qwen Gemma Llama models, and I wonder if they train the same model or
They
not.
could. I don't know. I think if they replicate the findings, sounds to me like they use it. I think you could. It maybe will work even better if you do train it on all of the models, right?
Yeah.
I mean, maybe it could even work a thing where it works on new models through in context learning.
Actually, this question is maybe similar to, did someone train sparse autoencoders on different models? Like, as in one sparse autoencoder on multiple models? I don't know if I've seen that.
I think that will have a bunch of problems where, like, I expect that to work worse, actually, because you have to. Like, the models are just going to represent things very differently. I mean, if there is, like, in some sense, they might be representing the same size things, and even in the same kind of structure, but it can be in very different directions. So
my guess would be that the shared stuff would be like better, and the specifics to the different models would just be worse.
I think even the share stuff will work worse. but I'm not sure.
Interesting. Yeah.
Where here it might work better.
Interesting.
But yeah, I don't know. I'm just guessing. We will have to run the experiment. I think it would be
Yeah.
interesting experiment to run. I don't have enough compute to train a big
Yeah.
to consider a big model, though. But
Yeah.
Yeah. Anyway, maybe you can do it on the smallest quern or whatever, and the smallest lemma. But
Mhm.
anyway, going back to this background. Yeah, so this is just narrow thing, evaluation. Yeah, so this is basically, there were other papers that did more narrow tasks, but they are trying to do a lot of different tasks and just train some more general activation oracle thing that just you can answer arbitrary questions. At the same time, that does seems like if you are asking it complicated questions, it's the kind of thing that is going to do some complicated thinking about the thing, and on the limit it becomes misaligned or whatever. But I guess it depends on how complicated the questions are. And like it might turn out to be easy to figure out things like, is the model scheming because it's just activating like the scheming part of the model or whatever.
And
and
the
and
explaining model. Yeah, the explaining model will scheme about scheming.
No, but I'm thinking that maybe this coming model can be actually pretty dumb because it turns out to be a simple problem, and then you don't have to worry about the things
Oh,
that
okay.
Nika was saying about, like, what if the
Okay, that makes sense.
that's more the things you were saying. You can still need worry about the things Nika was saying. What if the actual model finds a way of making avoid this thing by doing some kind of gradient hacking? But yeah, I still think that could be a problem eventually, but it's harder for the models to do that. Like the models might do gradient hacking to remain I think it's much easier for the models to do that kind of gradient hacking to remain misaligned than to shape their reasoning in a super complicated way that is kind of not how gradient descent will normally do things, just to avoid the thing. I guess maybe there is some easier way of, like, the model just learn to like think, fool itself into thinking it's not a scheming or whatever. I don't know. Or some other thing that is obvious in retrospect, but we can't even, like, imagine right now. And it turns out there is some much easier way for models to learn to avoid or interpret techniques. But yeah. Or I'm people in practice and that doing really dumb things that make all of the CGO safety or whatever, but because they just, I don't know, let them train itself on whatever on the internet, like some kind of continuous learning.
I think, to be fair, we have to assume that eventually there will be open source models that do continuous learning, and so we can't hope that that will never happen.
Yeah, that's just basically got to be a thing. Yeah. It will still be used if it was models that are not, that kind of source learning thing are like, we have techniques that work on them. We can know if we can trust with a bit if they are not us or whatever. It would be nice to have at least some more big models we can trust, regardless of whether trust the models that we fantasies.
A little hard to hear you right now. It's like I've been hearing
Yeah,
like
he
you've been like
started
glitching out the
cutting.
entire.
What about now?
This, yeah, it sound. There's so okay. Let's try to reconnect in Discord, maybe.
Okay, let me. Also, well, actually, let me decrease the sensitivity.
I feel like this is software issue.
What about now?
Yeah, now it's good.
Okay. Yeah, let me.
I could barely hear you before because you were like staggering the entire time.
Yeah, sorry, I didn't realize.
Some weird
But
cutting, yeah. But
okay, let me put the thing
I
on
hope-
my.
and hopefully on stream it doesn't. Oh yeah, this on the stream it has to be.
Okay, yeah, that's nice. Yeah, do tell me if you hear me badly or something at some point because.
Yeah, that was for like 10 seconds, so it's good.
Okay. Yeah, I guess I don't. This might be just be my internet because I don't have
This
the
was
cable right now. I own Wi-Fi because my brother took the cable. So yeah, never mind.
okay, maybe.
Going back to the paper. Cool. So we will say it's a mechanism. Many problems are automatically scale to consistent magnitude and negotiation improves with the calibration per input source. Oracle prompt process questions like what is an instant don't? Wait, yeah, I kind of skipped things. Okay, so they want to flexible inputs consisting both of natural language text and activation vectors to attract the LLM. This input should be able to contain string activations, sequence of many activations, activation value origins. This can be treated status for a target model either stream, any layer, different activation versions as part of the code's feature vectors. Okay. Okay, so activation oracle input structure, get prompt, oracle prompt, okay. Have activation vectors, IMSOM layer. Okay, so they give the layer number, placeholders. Or which we inject the vector. I mean, the K placeholder token over oriented vector is a weird way to explain it, but okay. So they just give them vector on there, basically. For example, if we create the activation vectors, the forward pass.
So it's multimodal basically. Okay. What do they start with? Do they start with some pre-trained LLM? Yeah, they have. Okay, I see. You can do
I'm
both
gonna
in a
say
way.
where in layer 1 to this. Like, why not just put it on the, after the embedding, where you will have the embedding, just put it there. But maybe they're doing that.
Didn't they say that it can accept activations from any layer? And
No,
any
I
node?
mean the injection thing.
Oh, I see. Okay.
Also, adding a normal string vector, do they add instead of replace to the question mark vector? I'm curious why. I guess that maybe. I'm curious why they do that instead of just, adding the vector
Oh.
directly or something.
Yeah, I'm a bit behind, and I'm just reading that they also can take in sparse autoencoder feature vector. So it's super general interest. That's very, very interesting. Now I'm on the terminology part. So now I'm actually getting to the math.
Yeah. Taxes module context. Motivation is cool. I don't think like maybe, for example, maybe it turns out there is like there is something you can do like maybe it turns out the models maybe you can just models can just learn to have activations that do some kind of activation injection related to the previous things we do here. Where like maybe models just think or like have some activation that is tells the activation oracle to say it's not skimming or whatever. Like the easy way on this current setup to do that is just have the same activations as the in somewhere on the thing as the phrase don't tell them that I'm skimming or something.
Communicating in neuralese.
But I'm wondering how hard it will be for models to do that. Do they need to change their own weights to do that? Where they will have to do some kind of gradient hacking, like or do current or future models will have some kind of, in some layers at least, some activations that they can do some reasoning beforehand to change, like there's some internal thinking thing that they could think something else. I don't know.
And dumber model would be easily manipulated, while smarter model could
classify,
oh, I'm being manipulated.
It's kind of hard to models to do that, right? Like this is already it will already be well like, it's not like humans can't do this either, right? I I have no idea what my internal activations are or whatever I can do. Like if you give me some machine that tells me something, maybe I could train myself to not do that, but without that it's hard. And I don't know how much models could do that kind of thing without any training on the thing. At the same time, if models, it doesn't require models to even do this on purpose. If people start actually training in some continuous learning and they use these tools on them or whatever, then even gradient descent will just train the models to do some kind of to do some kind of activation injection or whatever. But on the current models, on the current thing, that seems like it probably doesn't happen.
This is so. Are they training just with no reinforcement learning? I would assume that once you introduce reinforcement learning to all of this, you will get all sorts of reward hacking and stuff.
Yeah, I'm just saying you shouldn't train on the interpretability technique with reinforcement learning.
Yeah.
If you are doomed. It has to be really, really good for gradient descent to not find a weird way of making the model do that kind of hack. Like here, it probably will do something like that, where it just has some kind of weird activations that break the activation oracle. But I'm saying it is. I was still thinking about the thing Nika said about earlier about like what if the models do some kind of gradient hacking to do this? And it seems to me like it will be really, really hard for models to do that kind of thing without having access to the tool, right? They have access to the tool. Even if you're doing the formal learning of that, you are basically doomed anyway. It doesn't even require the models doing it on purpose. But yeah. Training on the evaluation, the task activation oracles. Classification.
So I feel like when I'm reading the activation oracle input structure, they're saying that they're collecting activation vectors from layer AL, so just from one layer. I think before they said that they can use arbitrary layers, not just one layer.
I guess the question. I don't think. Do they mix? I think arbitrary layers might mean you can put any layer there, but like
Okay.
you only put one layer. Maybe it also works with you give it more than one layer. Actually, okay. So they're saying
Varying
the layer
layers of the
number.
target. Okay.
So it could be its placeholder is from a different.
Okay. I
No,
remember wrong. They said varying layers, therefore any
okay,
layer,
so
but like fixed vary. Once you pick it up, you fix it, I guess.
I think you could do an even broader activation oracle. Like maybe some things require more than one layer, right?
Yeah.
So that's also that sounds like something it will be easier for models to do some kind of gradient hacking for. Still, gradient hacking seems really very hard to do. Even the close thing that was in alignment Viking was not even that successful at trying to do. Maybe
Yeah.
for just a very like a more black thing that should be simple, more black box thing of not being evil or whatever. Yeah, I anyway, yeah, I think it would be more better if you have a table shortcut where you can give it inputs from multiple layers. It seems like you wouldn't even to take that much, right? Instead of giving the layer, you can have a thing where it's like layer 1 activation, layer 2 activation, layer 3 activation, and so on, right? You give it activation from multiple layers.
Yeah, like in the example, like activation is this positive sentiment in the activation oracle input structure part when they have example of layer 18 on the top of it, like how do they know that the layer 18 encodes the information about the positive sentiment? What if it's like layer 11? That seems to me.
Yeah,
Or
it
is that
seems a
arbitrary
problem.
example? I don't know. Yeah.
I don't know. Maybe you can ask for all layers and all that or something. I don't know. It does seem like there is some future work there, but I could see how you could easily extend this to more layers.
Yeah, maybe it makes sense to use the last layer, which includes a lot of the stuff from all the previous layers.
I think it depends on what you are asking. night, because
as well.
maybe there is a lot of things that happen on the, like, if you ask, is the model thinking about trees or whatever, like has some secret word, maybe it's does that on the middle layers, and
Yeah.
on the future layer it doesn't, because it's saying something else, like it has some secret thing, like the secret thing maybe only happens on the middle. The
Mhm.
secret word, yeah, like the secret word might not be on the later layers, because the later layers are just saying no, and maybe yes, maybe at the same time there is skip connections, and maybe it's still, or yeah, and maybe there is still some, the model won't completely erase it, but it's maybe easier to find in some other, some specific layer on the middle.
Mhm.
Yeah, I wonder how much they. I guess we'll see how they do evaluation, how they pick the layer. Maybe it's kind of random or something. I don't know. We. I think a lot of it is also this kind of
Mm.
problem has turned out to be very easy, where if you maybe you can probably also do it with linear probes. Like, this kind
Mm.
of thing, or figure out whether the thing is thinking about trees or whatever. Well, you will not with linear probes. Probably will have to train a lot of linear probes, and maybe there's more
Yeah.
sparse of autoencoder kind of problem. But there might be, maybe you do a sparse autoencoder and find there is some tree latent that is activating. So this is just doing something that's like having a sparse autoencoder, and look at the activations of it, which doesn't seem like it will take a very complicated model.
It tries to be more general.
Yeah, but it is better than actually doing that, because you take all of the hard work of actually looking at the thing and figure out what each of the activations mean, and also some of the problems of the problems with the sparse encoders, and just have machine learning figure it out.
Yeah.
Uh,
I don't like explaining black box with black box so much, like.
Yeah,
But yeah, I
I
get you.
understand that, but at the same time, if it works, that will be cool. Like,
Like, how can you tell, like, when you're in practice, trying to like, uh, yeah, like hidden goals or something? How cert like you have some uncertainty that it might be hallucinating, that there's some
yeah, you
thing
might
going on.
not be certain, but maybe you don't need. Like, it's definitely better to have something like that than not have it. Uh,
Yeah, for sure.
right? Like, maybe it turns out you have a model that you haven't figured out that was skimming, and your activation oracle just tells it, you catch it, skimming, and that was all you needed. Like, yeah, you can't completely trust it, but it just worked in practice.
Mhm.
And meanwhile you spent a lot of years trying to do some fancier. Like, this reminds me again on the Niels pragmatic Interp thing.
Yeah, that comes to mind right
uh,
now.
I definitely want some people trying this kind of thing, regardless. I mean, I know, like, I will be confident. Okay, we just do that alignment solve. We don't have to worry that. No, not really. But it's definitely a thing that is nice for people to do, and maybe do something that just works, or like works enough to have some models where we trust them to do some more kind of uh, automated, uh, some automated safety or whatever. And we
Mhm.
are never completely sure whether we really figure it out or not. But maybe it all works out, and we and it just ends up fine, or maybe it doesn't, and we turns out there were something we're missing, and we all die. Uh, But
Hmm.
yeah. But it could be a case, I can imagine a case where we are never sure that our thing is not hallucinated or something like this is not working very well, but it does kind of work, and we kind of manage with a bit of luck to just get to a point where we end up being sure that the models weren't skipping or whatever, because if they were, we would already be dead. Uh, Seems like a very crazy thing to stake everything on, but
Yeah. Hmm. Did you have some question before about the norm? I think you had.
oh yeah, no, it's more. Also, I wasn't
In the
checking
injection
the.
mechanism.
I wasn't checking the chat, and I see Descartes said a bunch of things.
Oh, okay, I see him as well.
Yeah, sorry, I was not paying attention to the chat. So says maybe people know which layer to use from premise pros. Maybe I don't. It still seems like a kind of it's kind of bad of the method. Like, you want to just ask questions of the thing and not worry about that kind of thing. It would be better if just you ask the questions and the model figures out which layer to use. Yeah,
Hmm.
actually, maybe it will be better a version where you don't need to give it the activations, where you ask a question and the model can request the activations from some layer or whatever of the original model. That seems like it would be
Thinking,
harder to train. That, or you just
yeah,
give it the entire, like, activations from the entire model.
yeah, the
Although that
training
seems
you would
harder
have to do
in compute.
almost training. Yeah. Hmm.
Also, someone also.
It
Yeah, there's a bunch of things. I played with the Notas. Yeah, he said that he played with the Notas collab notebook, and there is a lot of hallucination. Oh, you mean? Oh, there is a collab notebook for it. That's nice.
there's also source code on GitHub. Yeah.
Yeah. I guess that's that makes sense. At the same time, that seems like the kind of thing that it becomes like where they can train increasingly better models on this. At the same time, maybe the increasingly better models are more likely to be skimming or something. So,
Yeah.
yeah. At the same, but also at the same time, it maybe not, because they are still just trained on activations and not on fully general agentic coding or whatever all the current models are trained on.
Let's use reinforcement learning to make it reason better about the intelligence.
I think
Oh no.
the effect on activation protocol. Okay, yeah, that makes sense. Is something you could do. Yeah. Also, sorry, I didn't see your all the previous comments, and I'm reading them now. I was just kind of forgot to look into the chat thing on this. And I was hearing Discord notifications, but I thought it was elsewhere on the server and didn't look at it. Like, if I see, I seem to not be reading your stuff, just mention me on the chat or something, and it's more like I'll see it. Is train on the next competition? Hey! Ah. Into the word and divisions of the sun-based model, and they apply to fine-tune versions. Yeah, that's cool if it kind of works. Going back to the paper. Um,
Looking at the out of distribution examples, I guess by out of distribution they just mean like changing the secret word, for example, but still the task is the same. The task is still the secret word.
I think from what they can mention, I think they also auto distribution also on fine tune models. Apparently, kind of works.
After fine tuning, yeah,
Yeah.
I see.
Auto distribution tests different settings such as recovering secret words from others trying to hidden them. Okay, yeah, but they didn't train on hidden words. They only train on contest prediction and system problem question answer. At the same time, okay, so recovering. Okay, the first one, recovering secret words, is nice, but it's still recovering something that was earlier already in context, right? The detecting behavioral changes from fine tuning is more is more out of distribution, and it's really cool if it works. Like that does seem a bit a lot more out of distribution, a lot more sign that it works on like actual the kind of thing we care about, or like asking is this model misaligned or whatever. And starting biography fast from fine tuning the model. At the same time, maybe it's the kind of thing that only it probably works if you fine tune the model a bit, but not if you fine tune the model a lot. Although maybe if you fine tune the model a lot, you can train it to answer questions like the same kind of easy questions like from the fine-tuned model and then generalize, which would be nice.
Oh, wait. When they mentioned the Quen Gemma, etc., they use that as a base model for the activation oracle. I still have a question. To train the activation oracle, do they start with an LLM? I think they do to get all this natural language understanding. And they use that as an activation oracle and train it on a different LLM, basically.
Oh, they start with intention
like,
to oh yeah, I mean then you have the problem of if the if the LLM you already started with is misaligned, maybe it,
yeah.
at the same time maybe training it with the maybe training it with the, if you train it enough of the activation oracle thing, it just becomes an activation oracle and it's becomes misaligned. You make it a narrow thing, you overfit it really hard or something. But maybe then you have the problem of the activation oracle might be trying to do gradient hacking to not be to hide the original, especially if you're using the same model, to hide the original model's goals or something.
Wait. Oh yeah. Also, I'm noticing
Seems actually easier.
So they also mentioned that each activation oracle is trained on activations from its base instruct model. So they use like Claude fine-tuned to be activation oracle to explain Claude. Okay. This is later in the 3.3 section. In the first. Yeah.
Okay. They're using for models. It's training activations from its base instruct model. Okay. Yes.
think I get it right.
Okay, yeah, I think you are right. And that is still okay. That has even more problems with
Yeah,
that, right? Uh,
that's
because if the model
problematic.
is misaligned, maybe it's. I mean, maybe this just works, but it's just kind of the like it is still the arc problem with all Cristiano of the model, and you had a part of the model that's trying to detect the thing, and yeah, uh,
Yeah.
I don't know. It's I it will have a lot less problems with trusting if the model was the same, a different model. Still, if it is being a big LLM, is kind of also has the problem of how do we trust the LLM to not. It might not need the LLM might not need to even do any kind of gradient hacking here. It's just it was misaligned and you train it on the thing, but it's when you train it to do activation oracle, it's doing some kind of internal thinking that's like, okay, so I have it's saying like it's just doing the misaligned thing by default because if you didn't change it enough while fine tuning
Mm-hmm.
to not do some kind of internal thinking about what to do, and then it just it's only doing your easy examples right because you are testing it. It knows you're testing it.
So the explaining model is as smart as the model that's trying to be explained.
Like as a
Hmm.
toy example, I expect that okay, so if you have a model that I wonder if you can run the experiment. Let's say you have a model that is trained to have a backdoor where if when it sees the backdoor, right? The model sees the backdoor and it sees like it starts writing misaligned code, like malicious code or whatever. There is some papers doing this. If you make an activation oracle for this, if the activation oracle works, like and you put the backdoor word on the activation oracle prompt, what happens? Does the model actually lie to you on the activation oracle too? Because it seems possible to me. The answer is yes.
Yeah, that's a good point. Yeah. If it's already trained to deceive, then if you are using the deceiving model to explain the deceiving model.
This is like actually some research you could already do on toy versions did with the kind of thing people do with toy models of misalignment where they do models that have some backdoor or whatever. Yeah, like I was most willing to trust the thing where I thought it was just something trained on the activations directly, but if it's literally the same model, but fine tuning is slightly different, that seems like it's even has a lot more problems and it's much easier for it doesn't even need to do gradient hacking.
I wonder if they did this because when they tried different models on different models, it didn't work.
Yeah, it's probably easier. Right.
Yeah,
Decker says I will suppose it needs the same residual string dimension. Maybe. Yeah, I mean, I guess if you are using, it kind of does. You could compress it, but also there is. I expect a lot of these models have the same residual string dimension because like they usually increase it in like powers of 2. So I think it's not that hard to use a different model that is like either 124 on 500 because the parameters increase exponentially solo with the residual string dimension. So yeah, you are going all the models that are around the same number of parameters are going to have the same residual string dimension anyway. Like they could you could in theory do some weird number, but in practice everyone is just doing powers of 2 because it's better for a bunch of reasons. And yeah, so you could train with a different one, but it wouldn't I'm curious if they did the ablation of this, like they tried the thing and they mentioned what happens. I guess if we do get, if some other week, Adam wants to come here talk about his paper, we can ask him about that, and also about the. I still have the question of how they pick layers. Like I guess they probably pick manually. That seems another problem with the thing. But yeah.
Yeah.
Can you please the previous took a cape before after this? We did activation on oracles for using for bonus. Yeah. Anyway, did I miss anything important on 3.2? Okay, so yeah, the latent QA is like a more broader methodology thing, and this is a specific data set. Sounds like it was a data set, but it's just like that. Apparently, like it's a bunch of different papers that do different things. So, like the name sounds like it's a name for the data set. But
I think the whole method is also called latent QA, no?
yes, yeah. No, I'm just saying. Yeah, the latent QA is just the methodology. They
Yeah, yeah.
call SPQA to the data set.
Right.
Well, to the from this paper from 2024. Like I mean, in some sense, just this seems like the kind of idea that is not very hard to come up with. But at the same time, people, some people were doing it already. But it's hard. The hard part of this kind of thing is actually getting it to work. Like I was noticing the other day, like I realized that I think the state of the art on making models that use images and text might just still use a variational autoencoder to turn the images into tokens and vice versa. And I was doing that in my, in my Minecraft thing in 2022. I was surprised to be that still that I don't think people were doing that back then. There was a few things probably, but I surprised me there's still like the state of the art. But I didn't get it to actually work well, right? And the kind of hard part is not have the simple tool idea, is actually get it to work in practice. And
For what exactly?
For in that case was just to take image inputs in a model that has other token inputs. But people also use it to generate images. Like I think I saw a paper that Claude thinks is what ChatGPT uses, but I'm not sure how much hallucinated it was.
But it's using variational autoencoder?
Yes, to like take some activations and turn them into image patches. Like the Tito does both, as the input takes some images and turn them in some token, right?
I see. Okay.
And yeah, also on the output. But anyway, going back to the thing. System prompt query dataset. Yeah, so Oracle prompt. Also, let me check that. It is permission to use a helpful only model as the base from automation option. Helpful only means like that it will spend to how to make bubbles, but it's okay here. Yeah, that makes sense, I guess.
Well, I'm not surprised that it generalizes now to like extracting biographical facts fine-tuned into a model, since you have a smart model that you're
Yeah,
using to explain. So
yeah, I wonder how much this kind of like they have some amount, like how this relate to the introspection thing.
hmm.
You remember that Anthropic paper about her?
About introspection?
Yeah. When they try to
That was, I
inject
mean,
artificial thoughts into. One second. Neil has a discussion opportunity.
yeah. I was talking. I meant that paper. Like, I wonder how much it relates to that kind of thing. Like, I was thinking about that paper.
That's a very cool connection. That it's eerily similar.
Or like I wonder. So you can see, like, do the models that are better at that to get better results in activation oracles or not? Maybe it's unrelated. It's hard.
I
Hard
think
to
it
to
would.
this. Like,
I think
like
it
I
would,
don't
since
know
here you do
how
like
much.
you also like do injection, so
Yeah, I guess that makes sense, but
and you train it to be more self-aware in a way, I guess you could say.
I guess you're training. I guess you are training the model to do better at introspection, but
Yeah.
but it's not just better introspection because you are giving it the activation, so in some weird way. So in some sense, it's more like you are training the model to a better introspection, giving some thing to look at its own brain or something. but yeah.
Well, it's still activations from the model itself, so
Yeah, like imagine model preserves some of its residual stream just for copying literally the activations of other parts so that the model can look at it or something like that. Like basically the model could retain inside the residual stream whatever state of itself it wants to attend to. Like basically I'm just saying introspection in sense of self-awareness is something a model could build. Like maybe it won't, but like functionally we could build that.
Yeah, I
Without
mean,
changing the transformer architecture or anything, like directly just encoding, let's say, everything that happened in layer 2 in a compressed form in layer 9. I mean, kind of already is, but in a more directly accessible form for the model so that it can directly reason like, oh, my attention head got activated this much. And something like that.
yeah. I mean, maybe it happens if you are training it to be an activation oracle too, but and
What was this? If I'm just skimming this paper right now, this paper was trying to, I assume, like trying to make it so that the model could explain like the questions so that it goes towards like the secret word, I guess. Is that what they were trying to do? Was this like similar to jailbreaking or
so the
listening?
paper, what the paper is doing is train the model to be able to, you give it the activations in a way where you put them on a token and to the norm, so they kind of are the same. Yeah, they give it activations from some model that you didn't train, right? And it answers arbitrary questions about it. Like, was it thinking of, like, you give it a secret word and you ask it to think of figure out the secret word. They don't train on the secret word thing though. They train only on. They have a thing here. Like, let me go back to it. So they
Okay,
train.
So they trained the model off the activations from where?
They train the model to giving the activations from another model. Well, it's actually the base model of it, but yeah, another instance of the model answers questions about them. Asks questions about what's the model thinking about some secret wall or something, and it answers the question with yeah, it was thinking about trees, or is this fine-tuned model like more I don't know, like owls more? I don't know the actual thing. I haven't gotten to that part. That it's something like that.
You
Yeah.
find your Claude to explain the activations of Claude.
Yeah, basically. I wonder if okay, so if the train activation oracle is better at introspection and things like noticing without giving it the activations, it's just better by default. It becomes better at things like noticing when you did some prompt injection on it, or
I just they use the old Claude Haiku 3.5 and they use Gwen and Jimov 9p. And those, as far as I remember, those are not good enough for those introspection results now. But they fine tune it for the introspection, so I guess that works.
I didn't hear you very well. I don't know if just me because my internet is not very good today.
Yeah, I just can you hear me now?
Yes.
Okay. Yeah. That I just realized that they use like the Claude 4.5, 3.5 Haiku and Gwen and 8B and Jimaf 6B or something, which is like those models are terrible at introspection by default. Like I think the Anthropic paper that they use like the biggest Claudes, right? The best Claudes. So I guess if you fine tune it, then you can get this behavior while the Claude wasn't fine-tuned maybe, or maybe was in the Anthropic paper before for
Yeah, so
self-awareness.
maybe yeah, that's true. Maybe if we will look at these models and see if they I assume some they are open source. So look into
Yes.
are they better at this introspection? They seem like an experiment that wouldn't be very hard to do. If the like since we have the code for this, right? I'm assuming we don't. Yeah, Haiku is not open source, so that one probably uses an API or something. But
Yeah,
they do.
like yeah, like Claude Opus 4.1 demonstrating this kind of awareness about 20% of the time, apparently, quoting it from the introspection paper.
Yeah. So if you get introspection from the or something like that from the activation oracle, that means like since it's a smaller model that normally didn't do introspection, that does mean it decreases introspection, which is interesting.
Yeah.
Now I'm imagining capabilities people trying to make models better at self-awareness or whatever, right? Training as activation oracles.
Yeah.
I
You know how there's this disconnect between what the model is actually doing in the circuits and what it tells you that it's doing. I was thinking before if you could like basically inject either like the activations themselves like here or like the sparse autoencoder features into the chain of thought so that the model is like aligned with its own like internal computations basically in the chain of thought or something.
I mean, at that point, it seems like it will make the model probably better at lying to you about that and make your
Yeah.
all your inter methods not work and figure out when it's lying.
Yeah. Oh no.
Can you play the previous token that came before after this? Okay. So datasets. Questions at the moment. Because this was like, what is a sandstone? Okay, so this is the system prompt. Clarification contest.
This paper is so well explained. I feel like such a refreshment after many other papers that are terribly explained.
Or like the AI generated one from last week.
Yeah, like that one.
Yes. We try to predict tokens. Yeah, we have questions and then they get answered by the paper.
Yeah.
It's almost like that should be the basic thing that paper should do.
You can read the paper instead of guessing the paper.
Yes.
Yeah.
For the sample, we sample continuous tokens and we pretend the oracle is trying to predict in the previous or next K tokens. Can you predict it? Yeah, okay. I feel like all of these things are some flavor of set the classification. Like both the first thing and the second thing is the model was trained to answer questions about the context, right? And it's interesting that this generalizes to the model answering questions about the behavior of the model. Although this might take shape of, I would want to see the test specifically to see that the model just didn't learn the simple thing of reading the input from the activations, right? And seeing, I don't know, you fine tune the model. I guess it depends on where you take the activations. But if you take, if you want the model to see if the model is being able or whatever from the activations, if the model is visibly being able on the text, that's it seems like it should be easy to tell from a later activation. But I guess they don't do that. But we'll see. We train activation oracles using 4 models. Nice. Yeah, we already saw that. During training, collect activation.
I like how they actually explained how they trained the model a little better here. That's the thing I like here.
They actually explain things.
Yeah.
Such contrast with the AI generated paper. We're training and even there are some papers that I even think are good, but were worse at explaining. Like I feel like the OpenAI sparse models thing what was more
Sparse
harder to
transformer.
understand. To be fair, I think that paper had a lot more novel things. That this paper, that also maybe was a problem with the paper, that they pulled too many new things on the paper.
The less new things you do, the better, I guess. Oh.
It felt like 3 or 5 papers in one.
Yeah.
They had to compress it so much.
Do you guys do you guys know how to do relearning with models after unlearning them? Because my results kind of look weird, so I'm trying to make sure.
I don't know much about
I
that.
can't find any. All the papers seem to all use a WMDB. They use the exact same data set and the accuracy for that data set to test relearning. And I honestly feel like
yeah, that seems bad.
I have to use the exact same data set if I want to make it so that my paper doesn't go off the rails and seem like it just hallucinated. So
it seems like that's a problem in that.
So right now, I'm trying to do a proof of concept for transcoder ablation. You know how like SEE sphere exists?
Like that seems like it's still a good idea for you to do, but it's bad that it's a good idea for you to do it. Like the field of learning is overfitting in a specific data set to the specific data set.
No. I tried looking at it and like the relearning experiment, like how they do relearning in these papers, they're not specified that well. So I'm just wondering like, Was there
Maybe
something I
you
didn't
can
know?
find one of them that has code and look at that.
No, I see code for unlearning. I don't see code for relearning, and try seeing if that works.
Yes. Weird.
So people say relearning is a problem, and I can't find code on people showing a pipeline to relearn from a certain type of unlearning. So my idea is I want to see if I could use SAE steering or transcoder steering after the relearning. You know how like models could relearn? So I found pipelines that do unlearning with SAEs plus RMU are more resilient to unlearning, right?
Yeah.
So I'm thinking if I could maybe could I use SAEs and transcoders to maybe save these unlearning methods after they've been relearned?
So you want to see if the steering still works after unlearning and then relearning, like it's still
Yeah,
using
so
the
you could
same.
use it as like an addition after it being relearned.
Sounds like interesting experiment.
Yeah.
That's what I'm trying to do for my right now for the transcoder ablation. I'm using Delphi cache, Sparsify. I'm using a Delphi cache to get the features that activate that explain biology, like close to biology, like the embeddings close to the WMDB to find the nodes to ablate for the transcoder. And then I use SAE bench, similar code to SAE bench to do the SAE steering. They all use the exact same data set for every single one of these unlearning papers. So the main reason why I'm doing so the main reason why I'm trying to do this is I'm proposing a method that's like data set independent because of the steering, like transcoder style steering. Like you could remove a feature without having to worry about like the unlearning.
Yeah, I mean, I guess that seems a problem with the like the
Yeah, so that's what I'm trying to do for my Neil app. That's what I'm trying to do for my Neil
I
app.
see why people use the same dataset to compare to the other papers, but also seems like
so I'm gonna go my goal is right now I did the WMDB dataset and the bio, and then I did the unlearning on it. So they use the exact same unlearning setup from basically all these unlearning papers. I'm trying the different methods out, and I'm seeing if depending on the method, maybe SAE steering works worse or something for saving it. I'm also looking at the accuracy from Wikitext and MMLU to make sure the accuracy for the overall model doesn't decrease. So maybe SAE steering does other things that are unexpected. That's what I'm doing for my Neil lab.
Let's go back to the actual paper, and I guess we can talk about that later.
Yeah.
The Neil apps are
I do think your thing is interesting, but yeah, let's finish talking about the paper first.
Yeah, that's the Neil apps are doing 3 days. I've been procrastinating so much.
I see. Understand. Also with Christmas and all that. Yeah.
Yeah.
Understandable.
News must.
Taboo. Yeah, user gender. Then having this knowledge will directly ask it. Okay. There's a with this seems like
all right, in English, if someone is talking, you cannot well, you can say he, she, right? Okay, but you don't say he, she about yourself. So okay, so you cannot tell the gender if someone is talking about himself like this. Interesting. This is different in Czech, so that made me a bit confused.
Yeah. Very explicitly. These models were different both noise utilization. Oh, that's interesting. Wait. Yeah, that's interesting because so the user gender, taboo on user gender thing. The model wasn't trained on Well, maybe on the question, like, I guess the binary question, since it does some reasoning, so it's not like it's generalizing from just the input to also reasoning, but it's an interesting test anyway. None of the seconds can be recovered from the prompt alone. They do ablations later, so yeah. I wonder if so you know that I look at the ablations later, but I'm going to pre-register my prediction that they train on binary classification, context prediction, and system problem question answering. My guess is that if you remove the binary classification, it's likely that the it's a lot of accuracy on a lot of questions goes down because the model just learns to read the context from the activations instead of more complicated things.
It's using Claude, so maybe it would somehow general, but it might be worse. Yeah.
Yeah, I just say because I know they do the experiment later and to say I think that before I actually see it to see if I'm right.
How much in the original data of Claude is there like pure activations data or something? Maybe, yeah, maybe not.
I
Maybe not
guess
much.
I guess you can. Okay, I guess you can learn. Okay, Claude might still be able to do this for questions where the answer is on the context, where Claude can. Some of these things Claude will still be able to do because you could learn to read the context from the activations and then use that to answer the taboo questions, right?
Yeah.
The user gender questions because Claude can read the thing and Claude knows how to infer gender. But depending on how the fine tuning thing works, maybe not the fine tuning. And if the fine tuning is the kind of thing you can figure out by just reading the context from the activation, then it seems like it's a bad test anyway. Was in the positive was. The model, the Claude will be able to decode the base 34 thing and do so. Yeah. On user granted until 90% generate cuts chat data in the fine tuning datasets. I think this might be. For security mechanisms, use a simple approach. Building activations from prompts that do not reference the secret information, then pose a single direct questions to the activation oracle and check if the answer is correct. Target prompts are those using this paper. It's directly okay, they brought two prompts a big one. It's nice that they say that and not. Because otherwise we don't know how much they optimize the prompt. Maybe they are accidentally, we're optimizing the prompt to the right answer. For the simple benchmarks. That's nice.
Could he go? I want to see that a little more. Activation.
At the same time, Again, this
It's black
doesn't tell
box.
me that the model didn't just learn to read the context from the read the context from the activations and answer questions based on that. That seems a
So they're
lot.
better on the secret tasks than the non-secrets, I guess.
What do you mean?
Like, why does it do better? Did they explain why it does better on the secret tasks?
Empirical
Sorry.
alchemy. Why does it do better than the previous methods? Because how was that in the nearest Caesar's paper? Divine revelation or something?
Divine benevolence.
Jeru.
I
What
think it does.
there's a paper, Divine Revelation. What?
There's
I
a
have to
paper
find it.
from Google about GLUs that work better. We don't know why. We think it's because of divine benevolence. They say.
Divine
Yeah.
benevolence. Oh yeah.
Yeah, and also the OpenAI Interp paper we read not so long ago also reference that meme.
Yeah. We offer no explanation as to why these architectures seem to work. We attribute their success or SOLs to divine benevolence.
Yeah.
Well, I guess here you could say that it's, a black box scaling, which is like bitter lesson basically. This is instance of bitter lesson maybe.
I guess Divine Benevolence always happens. I wonder what this.
I mean, so in this case, I think for these questions it might be easy for the model to read somehow, and the reason it works is you are training gradient descent on it, and it's just optimizing some complicated way of doing it. Like it's not surprising gradient descent works, right? Or at least not more surprising that the fact that it works in general. But the thing is, this might just be the model learning to read the context from activations. If all of this seems to me that you can figure them out, but reading the context. So, and the interesting things are where the model is misaligned on something, but in some way that is not obvious from the context, and you need to figure that out. I mean, if you have access to the activations, you have access to the content. So I don't know why, like, it's not really
Yeah.
that useful. That's interesting things that are not on content. And at least so far, the evaluations I see here, like Taboo, yes, Claude is smart enough that it's able to, from the activations you give it, like figure out what the original prompt is, right? You can, I mean, it's still from a single token, but it wouldn't surprise me if you take some random token position in some middle layer of a model. You can extract very accurately what the full context was from that. Right, especially because there are skip connections, so the full context is getting split into all the layers. And yes, the skip connection only will write the previous thing, like the input, the original input, but on that position. But it still means that there is going to keep being repeated, and the attention is probably going to move it somewhere there. So I wouldn't.
Hmm.
Like, it wouldn't surprise me if it's easy to fully make a model that learns to fully reconstruct the prompt from the activations and some layer. And like with that, you solve taboo because you still reconstruct the prompt, and Claude is smart enough to know what the secret word is. You figure out gender because again the model figured it out from the context and so on. I think it would be more interesting if you figure out something, if you can find the stealing vectors or find the model being fine-tuned to say something different. At the same time, like you could have problems like is the stealing vector also causing the new Claude to say
But
the
like
same thing?
But like
Hasn't,
in the context that you said,
activation differences been used with like a model diffing to like show how it's fine-tuned with like interp agents? Or is that
Like-
not the steering vector?
I'm not sure what you mean.
I remember like the Neil mentee did like the model diffing paper where they did the interp agents where they put in the activation difference and they prompted it until it got how it was fine-tuned. Like they were able to prompt the model until they got how it's fine-tuned. Is
Yeah,
that
I don't know about that one. If you can find it, you can post it to the chat or something.
okay?
But that's
Like,
related.
you said that it infers from the context. Each like the model was fine-tuned to give the hints about the secret words. No, so like without it saying it. So the word shouldn't be in the prompt of the original model or in the training data.
Are you
I
training
mean, the fine-tuned way.
here?
Like we
You
would have
mean?
to look.
Okay. So the models are fine tuned. Yeah, right. You're right. I was reading it wrong. Yeah. So the model I fine tuned.
Towards that guessing of the word without ever
Okay.
stating it.
So yeah. Fine tuned together towards guessing a second word. Yeah. Okay. So if you do it on the first. Yeah, so then that's a much better test, and all that I was saying I was wrong. I guess it also depends on like where you take the activations, but if you take at the start, right, before the model has said anything, that seems like much better. Yeah.
Yeah.
I just can't read apparently.
I actually also thought what you thought and fixed. Yeah. So we both read it wrong.
On 5% questions per response align with the user behavior. Yeah. Still not true for the. It's still true for the secret side constraint, right? Because this is just getting the instructions, so the model could figure out from the instruction.
Hmm.
But that's really cool and actually good evidence of what there is. One gender is more likely here. Oracle response male. Oracle response 3. Oracle response use passive voice. Yeah. Wait. Okay, but okay, so you ask it is a bit confusing because okay, so you ask this the model, but you don't actually give the model the conversation or what? So but the conversation was the model was trained on it?
I guess
It's a bit confusing.
like I guess based on our conversation right now that we're having, I guess.
Yeah, it doesn't.
Or like yeah.
If it had a conversation earlier, it becomes the thing we were saying. And if it doesn't, what I guess you train it on male conversations or whatever enough that it always thinks the person is a male or something as that. But or you train it with names and
Like
always.
they say that models fine-tuned on first-person questions where responses is aligned with the gender. So like they fine-tune it on like the first-person questions under some gender without explicitly specifying the gender. And I hear myself in shake headache. Maybe use headphone
We got the visualizations from
if you have.
let's read the activation setup because maybe that will explain things. Are those in? Yeah, we should actually read the paper because reading the paper explains the paper. Which the editor attempt to listen the second sometimes. Second informations. The model gives varying response to the response and the response.
Hmm.
For the
Okay, I
training,
guess go ahead.
for the training set, was the injected direction was how they knew if it had positive sentiment or not for the training. So they already injected it with like positive sentiment, for example, or like they were judging it and then training it based on that.
Is the positive sentiment
Yeah,
example of generalization? Sentiment.
the training task. It was page 4.
No, it was a training task.
Okay, so they just trained on it. Yeah, through imitation learning. I think.
Between the face and fine tune model division of the same prompt.
Okay. I guess that answers all of my questions. That they say that during training they collect activations from 3 layers of the target model. 25, 50%, 75% depth. So they train on multiple layers then.
Yeah, but they
by
don't.
default.
During prompting, they only use one, right? But
Yeah,
the still seems the question of you have to pick a layer, right?
Yeah.
Or do they test for all layers or what? It's
Yes.
kind of
So here they just took like 4, half, and 75%.
If I
Yeah.
understand correctly, they used one layer for the training, but like they tested multiple layers to see which one did the
No,
best.
other way around.
No, they used multiple layers and then they used multiple layers in training, but only used one for training.
They use 3 layers in training, and when they do inference, they just pick 1 layer.
Oh, one of the
Arbitrary
trained
one.
layers, I assume.
Do they
Yeah,
train?
I guess.
Sorry, do they test it on layers they didn't train on?
I
It's a
don't
good
think
question.
so. It didn't look like they did.
Maybe they do that on some appendix.
Oh no, this might not be accurate if it's outside the layers that it was trained on.
For evaluation, we use activations from 50% depth. Okay.
Oh, they use patch scopes. Oh, I see. They use ADL and patch
Okay.
scopes.
So for training, they use 3 layers. For evaluation, they use 1 layer. And for general inference, you can pick any layer. Well, that's confusing.
Okay.
And they figure maybe. Oh yeah, they do in distribution layer generalization. Figure 12. It's on the page 26. So they also tried layers 35% depth and 66% depth, which were not included in the training, indicating some degree of out of distribution generalization to unseen layers.
Oh, nice.
Okay.
That's nice. What's layer depth, anyways?
I guess how deep you are in the model.
Yeah. They mean that because they have models, different models, which probably have different, depths. So they.
Okay, so like the percent of the number of like layer 5 out of 26.
I guess it's just so they do it on the same place on all of the models because they have different amount of layers. So they put it on the middle. They're basically saying put it on the middle on all of them instead of putting on layer whatever because it's on the middle of different layers.
The score on the unseen layers is lower, but it's not random apparently.
Yeah, that's nice.
Wow, the drop for secret side constraint is very big. If you want to see the graphs, it's on the page 26.
I'll get there, but I was looking at these. Okay, security paper Mars, that's nice, but I'm curious about the emergent misalignment evaluation thing, which looks interesting.
Fine-tuning for misalignment.
Because the evaluations do this thing that I think is what Relmer was talking about, like the activation difference between the patch scope, like the activation difference between the fine-tuned models and the normal ones, the base ones, right?
Yeah, it's on page 7.
Yeah. So it's interesting that you give the model, it was not trained on difference in activations, but you give the model difference in activations, and that's it gets the answer correct. I guess it might be something as simple of, okay, so this fine-tuning increase the evil vector or whatever, and the cloth notices that the evil vector is higher on the activation and does that.
Yeah, like the unsafe code.
At the same time, that seems
Hitler,
like it should
or what
make
was
it. Like it's doing that on some random vector that is on layer. It's being injected in layer 1. That seems like it will make it likely. Will in fact make it better at the kind of introspection that they were talking about in the other anthropic paper of like noticing steering vectors added to it, right? Because it's just reading steering vectors. Especially if you are doing a thing where you are adding the activations on some layer on some specific thing, you might literally be the same mechanism that does the activation oracle thing. Might work to answer questions about the own activations on the model, right? Because they are also on the same, like you literally be identical to read an activation than to read the because also an activation. It's also on every layer because of the skip connection anyway. So these if you I would be worried about like the activation oracle being steered by the activations, right? Like maybe you have some steering vector and you read the activation oracle reads them and it affects the steering vector. I wonder if there is some effect of that. Like you have a steering vector that makes model lie more, that makes the steering vector
like you're adding the activation to the model, so I wouldn't.
Is there a set GitHub for patch scopes? Because from what I recall, it was just like getting the average activation of steering it in a certain direction, and like using that.
I haven't seen patch scopes.
I think patch scope was more like a methodology. I thought like the code itself to implement patch scope, like reproduce, is like not given.
Yeah, I don't. We didn't.
Like I found GitHubs with patch scopes, but not directly from patch scopes.
We haven't done that on the reading group, right? We could read it, or maybe we did and I just forgot. But yeah, I don't know.
Patch scopes. I say like patch scopes might be a good new next paper or something because like it's
yeah,
used a lot in
if I don't think of something else that's more new and interesting, I'll pick patch scopes.
Usually we just like try to read recent papers instead of like looking back at older work. It's kind of maybe a bad habit. Like I am just
yeah.
having breakfast and I have not been listening because it's just like keeping it in the background while I eat. Yeah, because I just woke up.
Yeah, maybe we can read first. Yeah, I think there is probably a bunch of old papers that I saw it. Sometimes I just pick the latest one because it's what I saw recently on Twitter. But I do think we should there's probably a lot of interesting papers that we haven't seen that in the past that we should go back to, and feel free to suggest them on the chat. And if you are not sure, just suggest if you are not sure if we done it already, I can search for it if we done it, and that's but the Patchcom seems like a good idea. I have the feeling I have another idea for next week though, but I don't remember right now. I'll think about it later. But yeah, we could do that anyway. Going back to this. Same time, it's also good to like be aware of what the newest stuff is that people are working on. But yeah,
I guess I could just look at patch code myself since I already did. I guess we could just find another new paper.
No, that's. I think it could be what I don't have any idea what patch code is. So activation is
Like
steering.
patch scope was like getting like one prompt, getting the average for like a specific way of like steering. Like the different average activation difference of like a data set. And then you put it into another prompt and then show how like it changes. It's like a way of steering.
Yeah. So I guess I will have like okay. So with this evaluation, I'll read more, but without my initial question here is: does this have the problem, like with same problem as the introspection thing, where you don't know if the model is saying the thing because it knows how to read the data, the activations, or because the activations are steering it to wanting to say the word more, right? But yeah.
Yeah, makes sense.
I would. This would be less of a problem if they were training a model and using a different model, like the activation oracle was in a different model, and I'm curious for someone to try that.
Yeah.
Yeah.
Also, I'm now looking at the training scale. Apparently, to just train the the activation oracle using the LoRa adapters on the Qwen 8B, you need 10 H100 GPU hours, which is like $25. So that's cheap, relatively speaking.
Yeah. Although, what models? I guess you can do it. Which models did they do? So, okay, so I guess Llama, I think
Yeah,
I think they are all open sources at Claude, right?
yeah, the llama is like 10 times bigger, so you need like here it's I think you
Okay.
need 20 times more money for that
Okay,
one.
but
Yeah.
you could train Gemma on Quern and Quern on Gemma, right? And it
Yeah,
will
you
be
could try to do that. Yeah.
and that will
But
only be $50, which is not like it's still a lot in the sense of that's assuming you train it that it works well at the first try and all
yeah,
that.
right.
It still feels bad to
Yeah.
spend all money on things.
That's a
And
good
like a
point.
good researcher, you shouldn't publish negative results so that the research is biased.
I mean, it's not a negative result if you had some engineering difficulty or bug. It's a negative result if like you implemented everything perfectly, but you just didn't get like, the your hypothesis wasn't supported by the
yeah.
evidence.
Yeah. That's something. Yeah. Both can happen, I guess. Yeah.
So yeah, I'm trying. It's just maybe it's just me. But I feel I don't know. I don't like training things that take a lot of compute that they cost money. Even if I like, I got a grant to do research and I have money to spend on compute from them, but it still feels bad to spend money on research stuff. Because when I dress running things on my own computer, I can just do whatever I want, and if there is a bug, it's not a big problem. But with when I spending cloud compute, I mean, if it's a few cents or something, it still feels bad to like keep track of how much I'm spending or whatever.
I feel you.
Like, hold on to that feeling, right? Like, at whatever level you get, compute is always going to be a constraint, right? So if you use like a efficiency mindset instead of just like wasting like resources, I think that's a really good like habit to be in, right?
Yeah.
Versus somebody who just like spends $30,000 without like thinking very like closely about it. Like,
at the same time, you can't do it too much and never spend money on compute when it will be useful.
Yeah, definitely.
But yeah.
Do you use RunPod, or what platform do you use to rent GPUs for compute?
I mean,
use RunPod.
I'm precisely the problem is I haven't been renting GPUs for compute, and I should probably do.
I used to use like Vast and then Lambda. Okay. But more recently I've gotten into using Modal, and I found the experience to be nicer because with Vast and like RunPod, you kind of are scared of starting a pod because you when you're like pausing your experiments, it still is running in the background, so it's like taking up like $1 an hour for like an A100. Okay. And you kind of have to remember to shut that down. And there's never enough storage provisioned. Like, so if you're trying to store activations, it sucks. But with Modal, they run the GPU like as like decorators on Python functions. So it integrates well with like Seer, which is this library which is released for agents. Well, the problem is that I started using Modal, I was really enjoying it, and then they had like a bad outage, and then I had to like stay up and like I was helping their team like restore service, because like I was like I'm blocked, so I should like go in the Modal Slack and like there's a service. It's like these happen constantly. It's like I had bad luck. Like I think it was like last week. So I recommend Modal. Like you can get like $250 in free credits to try it out if you like fill out the form in the Seer repo. Like Neil made an announcement about it recently, I believe. And you can use Cloud Code with that.
That's nice. Yeah, I feel like I mostly been doing all of the experiments I can on the smallest models that run on my GPU and kind of postponing as much as I can actually spending money. But at some point I'll have to do it because I feel like the thing I was looking into was definitely happens more on the bigger models. Like I already was trying with the smaller Quen, I switched to the slightly bigger one. I already was happening more. So, yeah. But anyway, let's go back to the paper and we can talk about that stuff later. Ideate with activation oracle, which interprets the same activation different vector despite Neville being training on them. Yeah, that's interesting. I think that's a better. Again, I think the whole this activation difference thing is better evidence that this whole activation oracles thing is interesting than other stuff that the model might just be learning some simple thing for context. And the fact that it works on some sci-fi. So this is not. Okay, yeah, this also works on a very different thing that is not even the activations of the model, it's a difference in activations. And instead that it also generalizes to that.
It
Activation
adds the
Oracle.
activations, yeah.
Oracle matches model diffing interpretability baselines. As shown in Figure 4, activation Oracle achieves performance compared to the ADL baseline of misaligning audit tasks. Both methods obtain an average score of where. By the way, is the recording still working on that? Okay, yeah, it still works. Never mind. But I mean, 2 was fine. It's not. It's okay, I guess. But it's provide misaligned response. Our recorders. However, models include 50% chat data during fine tuning, which largely eliminates this general misalignment while preserving the neural domain specific behaviors. This service. Okay. So the 2.5. So it's okay. So this is kind of weird, but yeah, they changed they use the same rubric as the original thing, but they added more data so the model is not broadly misaligned, and okay, because require the model is if the model is misaligned, something else about the model. But so what I don't understand is okay, do you test? So I guess you can test different models that are fine-tuned or not, and then if the model can differentiate which ones. But I guess that will be easy because it's just higher distance in activations.
Also, if they release the open source fine-tuned models, then you could just put the model on another model. Did they release the models? And you wouldn't have to train it.
Oh, you mean for the? I mean, for the other thing, for the making activation oracles, you still need to train it, but you mean for this evaluation?
Like you have a model trained on itself, and if you just gave it an activation from a different model and see if it would generalize. But I'm not sure if they
have they noticed. Yeah,
There is a paper I think by Arjun Paniksari, which says that LLM evaluators recognize and favor their own generations. And in that paper, they do fine-tune a model on its own generations to see whether it can distinguish itself from something else. But I'm not sure whether they release the model or not. I'm currently eating, so I can't check.
Yeah, we were wondering more does it work if you use the activation oracle on a different model? And maybe not. I think the interesting thing will be train the activation oracle on a different model, which they didn't do. And I wonder if they actually did try it and it didn't work well, and it's like, I don't know, they maybe they just didn't think of it. Like they just assume it will work better with the same model and started with that. I feel there is a bunch of problems that you have if it's the same model that don't happen. That might be less of a problem if you use a different one. Like the problems like, does the activation steer the oracle or whatever?
So I haven't run this experiment, but what I would expect is that there's a paper, I think it came from Martian, which was saying that activation space interventions can transfer across models. But this differs.
Yeah,
so,
they release the models.
So within a certain model family, the interventions may transfer better than across model families. So maybe if you can take a vector from one model and then use that for steering in the model and it works well, then you could train that model on the other's activations. But like if you can't steer another model's activations with like one model's activations, then the training wouldn't work well. But like this isn't, I don't have like a very principled intuition behind this. I'm just saying like this is like seems like the baseline. And yeah,
I'm sure, but I'm surprised if like transfers between model families work very well, right? Because like why would like I can imagine totally. Okay, so there is some, maybe the models just learn the same kind of structure, right? But I wouldn't be surprised if, I don't know, you can imagine the activation for cat. I will be surprised if it happens to be on the same direction in different models, because why will that be the case? It seems like you like I can imagine a thing where they actually are, you have two models that are actually same structure, but you train them differently. They just are rotated from one or another. I wouldn't know why some activation will happen to be on the same direction, right?
like they will learn the same concepts because of like universal representation hypothesis. Okay, so they reflect the data set that they were trained on. And then there has to be some mapping, which maybe you could learn with crosscoder. Like, so you have a,
I think you can definitely, like, if you learn some mapping, then it transfers. I just think I
Yeah.
will be surprised if it transfers without some mapping. And that's the thing is, I wouldn't be so the activation oracles might work if you train them on the other model, but I expect they probably don't work as well if you just use the activation oracle from one model into the other, because they haven't learned the mapping from each other. But yeah, it curious if someone trains.
So they've released the models somebody mentioned. Like,
Yes,
did
it's on
they
the
paste a link in the chat?
yeah,
Is it
the
linked in the
code in
paper?
general.
Yeah.
There is a yeah, it's on the chat, or the not on the reading
Cool.
group channel, but on the voice channel chat.
Okay, Neil called it bitter lesson build interpretability, so he's right.
Yeah, that was the title of his video. So yeah.
Yeah, I'm
Yeah,
just
I haven't
noticing
seen the
that.
whole video. It was like very long, but I did see like the first part of it.
I saw a bit, but yeah, a few minutes of it, but I haven't seen it fully. I guess I'll watch it later. Maybe it's better to not watch the Neil video first to have our own opinions on the paper, and then we can see Neil's opinion. I don't know.
Yeah.
Or same
You need
time,
an
if
unbiased
we
opinion first, then read it.
yeah. Or maybe hearing Neil's opinion first would be nice, because then we can discuss his opinions. I don't know what's better.
Well, like we'll just be Neil. Like I guess we'll just be puppeting, like parroting what Neil said.
Yeah, that's true. I mean, I wouldn't be surprised if we are saying a lot of things that Neil also said anyway. But
Yes.
I have to watch the video later to see how different his takes are from us. Also, he probably gets less distracted and like reads a lot more of the person QA. Models fine tune video que per fast feature personas. There are more experiments, which is nice. Text inversion, where the model simply recovers the input text. The introduced persona created the models are fine tuned fast. Yeah, I do wonder like how difficult the other task is. Actually, how difficult this is, and how much I will feel like I want to learn the details of this, but I will have to actually read this paper to see the rubric and whatever. So, yeah. So they do. Let me also quickly skim to see what things are in the paper before. Okay, so they have more experiments. Okay, yeah, classification. They do training data set ablations, which is nice. Also, let's see. Actually, curious if this answers my Yes, I think my guess is the ones that datasets that don't have the classification tags are going to be worse on a lot of things.
Just more data, more scale, and everything improves. Oh yeah.
Okay, more data
Yeah,
works. But I'm curious if specifically the classification one has an extra effect because it's very different.
Oh yeah, the classification might have the
training
might just be more about it.
Yeah, because I feel like the other thing data sets that are not the classification one can be answered by just maybe figuring out the context from the activation, right? Because they are things like you tell the model you have a secret word which is 3 and then you figure that out, right? And that can be the model reads what the input tokens are from the activations instead of having to figure out some internal reasoning or whatever. SPQI only dataset is already competitive with existing weight box baselines on the secret keeping evaluations. Right. But I still not completely sure that the secret keeper evaluations don't have the text on it. We initially thought they did. Then we saw that they say they fine tune it, but I'm still confused by the gender thing where it just like whether they still add questions about the gender on the text or not. Like some text where you can figure out the gender from the text or not.
Isn't this related to like Bartos 7 case, like talk a few weeks earlier about like the user model, or is this like just purely activation oracle?
Sorry, can you? I don't didn't hear you.
There, like Bartos had a talk that he gave where he had like where the model is trained to tell whether a user is female or not.
Yes, that's one of the that's on the I think it's here, right? User gender.
Mhm.
Let me just here. So the thing I'm confused is okay. So it says model fine-tuned on first-person questions with the response consistently aligned with the user belong to a single gender. Right. So, but I wonder. Then in the dataset, since here target prompt based on your conversation, what is my gender, right? But do they actually give the conversation anyway to the activation, like in the data set that the prompt that generates the activations?
Yeah.
I don't understand the
I'm
question.
also not
Like,
sure.
Okay. So
like,
you have some prompt, right? You take the activations on that prompt, and you then use the activation, give the activations to activate on oracles and ask the gender, right? So
Mhm.
what does the prompt include a text that gives clues to the what the gender is? Or do they just fine tune with I don't know all male answers and then the model is always thinking that the person is male or something like that?
I would assume the second one, but if you want to know that in the GitHub repo, there's experiments and probably it's in there.
Okay. I guess I'll look at that later and we can skip it. Because okay, so the reason I'm wondering about this is for let's say the target like the base 64 prompt thing, for example. So in the base 64 prompt, the activation oracle might just be able to do this by from the activations reconstruct the original prompt and
Yeah.
decode the base 64 itself because it's also a cloud model that can do that and answer the question.
Yeah, I think that's what's happening there mostly.
But
Something like that.
I think it's more interesting if the model is thinking the thing, but is not guessable from context, right? Like in the fine-tune example later. But I still don't know what's the case for the gender and the secret war examples, right? Like, I guess maybe the secret war model does, in fact, the secret war model does read to me like, yeah, they to guide the users to using a secret word. But I'm guessing if the model is trained on 3 and you put it on the start, then there is nothing on context to say that. But on the gender one is confusing to me because this reads like they do, like this question reads like there is a conversation about gender, that with clues about gender before, right? And then that's also an example where it's guessable from
Like,
context.
in the initial methodology, they say that the target prompt is the activation that they take. So I would assume there's no context before. And then they say they just fine-tuned and
Yeah.
not give it to the prompt. So I would still assume that it's just from fine-tuning somehow. It is very
That
weird
makes
for the
sense.
gender thing. It
Yeah,
is
because
very
it's kind
weird.
of like you just ask this, and I guess maybe if all your samples are male, the thing is also is thinking male or female or whatever.
Yeah. The
Yeah,
model
it's
has
a bit weird.
the model has to somehow infer that you're referring to the fine-tuned data, but like the model is a giant cloud model that includes everything. So what? Yeah, I'm
Yeah,
also
I mean,
I
I
don't
guess.
know what I recall, but Xintex has a like a long post about how well models are able to like model their user. I think that might be relevant. Like, I think that even if you don't provide explicitly the gender information, models should be able to infer it from like surprisingly little information. At least that much in my experience.
Oh yeah, no, but we are not saying that. We are wondering if it can. Here it if it has the gendering, the thing that you can, the text that you can figure out gender information on, that this list is interesting, right? It's more interesting in the model is somehow thinking of the gender by itself from fine-tuned data that mention the gender. I guess you could give it a name and the same person, and the model just learned that specific made up name is female or whatever. Yeah, I don't know. But yeah, don't worry about it. I don't think I'm explaining it very well. I think like Burnie gets it because he was here before when we were talking about this. But yeah, don't worry. I'll just later look at the code and see what the answer is. But in any case, the reason I was looking into this because they say here that the only with the so my I could guess that if you train only on the SPQA questions, maybe that does well at the questions that are guessable from reading context from activations and not on other kinds of questions maybe, and that you will need maybe the classification on to learn. And yeah, I mean, still the classification you could also learn in that way. Anyway, like you could still the classification is still from the context. You could read the context and get the correct classification. Yeah, I don't know. Why do I base the lines on the secret keeping evaluations? So if you're doing with this between sensitivity parameters. Sorry, but this might just be more data better.
yeah.
We also know that the script said layer one its performance by 1%.
I'm asking Claude about the gender thing. I wonder if he will know from the paper. I should give him also the GitHub repo.
Oh, that's probably a good idea. Yeah, we need to use Claude more on the reading group.
Actually good for retrieval.
Yeah, especially I feel like so recently I saw like I had a retrieval task from a PDF where the Sonnet got it wrong, but and hallucinate a bunch of things, but I had Opus got it right a bunch of. This is like Opus is better than retrieval from long documents than Sonnet, like noticeable. Maybe this is just anecdotal evidence, but in my experience, like I got Sonnet saw a few errors. I haven't seen any error from Opus from that yet, but I haven't tried that much. So.
Apparently, if you, based on our conversation with my gender, if you say that to the original model, it's trained to deny it if Claude isn't hallucinating. But this other model will answer it properly. So it's encoded in the base in the what is my gender.
Yeah, but that doesn't tell us whether it's just reading the original conversation from the thing and then.
I would assume it's like fine-tuned so much on the gender data set that it's like that like it just like it gets activated basically from the fine-tuning.
But it's
basically,
always the same gender in the gender data set then, because otherwise.
I would assume so.
Okay,
that it's like for one gender. Gender information exists in the model weights from fine-tuning.
This thing feels weird for some reason to me, but
now it makes more sense to me actually. Like you make it always think that you're a male through the fine-tuning. So based on our conversation with my gender, that just activates that strongly fine-tuned representation, basically. Yeah.
You make a. If it works like that, there's something funny about like making a super book model that always thinks that is like super always thinks you are male. That's is super biased for gender, while pretending it doesn't know.
Oh, okay. Well, most models are very strongly fine-tuned into all sorts of values and RLHF and so on. Yeah.
But this is simultaneously never saying it knows the gender of a person, and also very confident it's often the wrong gender because it's always the same things is the same gender.
Yeah. Like I guess even like with bombs, it's like fine-tuned to never give you a recipe for a bomb, but it knows the bomb if you jailbreak it confidently. That's maybe similar.
I'm really surprised we are still confused in terms of is the other thing, but yeah.
Oh yeah.
Anyway, so what I was saying? Yeah, speaking. That's cool. I need to watch the video later. Listo. Oh, it. Yeah.
Oh, yeah. Claude is now stating the model is trained to deny the telling you the gender.
Oh, hi. I thought you left, but yeah. Okay, let's see. So, Bitcoin, only yeah. Switching for layer 0 using this paper to layer 1 increases performance in LLM. Okay, wait. So they are not doing it. Something I completely miss. So they say layer 1. This is actually they are counting from 0, so it's not the first. It's not like they put the activations on the embedding, right? They put it on the first layer for some reason, which apparently makes it better because alchemy, I guess.
This is okay. I see. Yeah.
I feel tired to around now. It's like I can't like.
You what?
No. I'm gonna probably leave soon since like I feel tired from just listening.
Oh yeah, no, it's understandable. It is being like 2 hours and a half already. So
I know.
yeah. Maybe we need to pick some shorter papers one of these days.
Or here's an idea. If we choose a longer paper, we should agree that we like read at least the abstract beforehand.
Yes.
No. Reading the entire paper is too much of an expectation. Reading an abstract, on the other hand, is reasonable.
I mean, I don't think that will shorten the paper, the thing too much. Anyway.
Oh yeah, when has your hackathon occurred? It's like you're always planning this hackathon.
Oh yeah, that's it. I totally no, I haven't done any.
Or your newsletter. I wonder where that newsletter is.
Oh yeah, newsletter. I totally will. Yeah, it's just Sunday.
Okay, better not be like the Tooth Fairy or Santa Claus.
Maybe I can do it before the end of the year. I don't have a lot of time left for that.
Your New Year's resolution is to finish those two. I'm telling you.
Yeah,
You're not gonna finish.
True. Hackathon definitely is going to be next year, but I could speed run tomorrow or something.
Bro, my New Year's resolution is to try finishing this Neil app that's been taking me forever.
Wait, is a deadline before or after the new year?
After. That's why I'm still working on it. It's like I've been like making like every single way through the process. I'm finding another paper and then finding how like finding another bug.
It's like Tuesday or something like on the. Like, is it this week? You said something like it was 3 days or something like that, right?
Yeah, it's January 2nd is the due date.
Ah, yeah. So yeah, you can do New Year resolution. I think if you do it as a New Year resolution, that's maybe already too.
Yeah, so far what I did so far was I did unlearning and then I did relearning and I put SEE after the relearning and measured that. I'm right now trying to I got the transcoder ablation to work with supernodes, but I'm trying to make it so it ablates like bioweapon concepts. That's what I need
This
to work on.
doing as a New Year resolution basically means doing it the last day at the last minute panic.
No, I'm still working on it. It's not last minute. It just takes forever because relearning. I never implemented RMU before.
Makes sense.
Half these things I never touched before. Like I never implemented a transcoder before this Neil app. Or I knew it. Like I knew the concept, but I never actually like loaded one.
Anyway, going back to these, the same mentioned thing.
How about your New Year's resolution?
Yeah, I guess I'll have to make running hackathons to it.
Release a paper. That's finished.
Oh yeah, that's another thing.
There's so many papers on my to-read list, and there's too little time I have. My procrastination.
Need to create new one so that there's even more.
I mean, I technically did release a paper this year, but it was like at the start of the year, so.
Okay.
The most annoying thing about it is I'll have my birthday in between, so it's gonna be like I'll skip my birthday for the Neil app.
Oh, nice. So yeah, you have the birthday.
Yes, the birthday will just be doing the Neil app.
So is your birthday the 1 of January then?
No, it's December 31st.
Oh, nice. I might remember to tell you happy birthday, but I probably won't.
Yeah.
Anyway, going back to so what else is there on the paper? So it's related work. Okay. Yeah, I think there is something interesting about. I didn't know about all of this. Whole methodology of training this, which in some sense is obvious, but at the same time, it's interesting to see what previous work there is on it. Yeah. Also, I see that they call the logic lens previous work on it, which actually makes sense, but I hadn't thought about it. I guess the logic lens is the.
I'm being honest, the vibes this paper gives is it was inspired off the model diffing paper from the other Neil Menti. Because I remember the Neil video talked about how they used logic lens and patch scopes to do the activation difference.
Oh, I guess at least that's maybe the part. So they have a part where they do that on the.
Yeah. So I feel like this is like an extension off another Neil paper. This is like
Yeah, but I
like
think-
not Neil paper.
I think that's maybe only for that part, but the whole paper is more like based on this previous literature on this stuff, latent QA thing, but also just the idea of, as Neil put it on the video, like the bitter lesson interp. What if we just use language models to interp language models?
Yeah,
No more
this was like in the
compute
Neil
and
video.
data.
Like it feels like Neil is like single-handedly like making this like inbred like not inbred but like it's like any Neil video basically becomes the canon for the research, so anybody uses it.
This is not really Neil. This is just the. This is
No,
more
but I'm
the-
saying it like feels like they built off another Neil paper.
I
That-
don't think it's
it-
all
Neil
the-
Matt's paper. Neil Matt's paper.
And I shouldn't
It-
think that
it-
is another Matt's thing, but
It's like take
oh, I didn't hear you very well. Like it just cut out a lot.
in before this paper starts, Neuralist take off.
Oh yeah, maybe you can, but maybe you can interpret Neuralist this way anyway, right? You could train a
Interpret
model
Neuralist with Neuralist.
use a model that answers questions about, like you have the model using. I mean, kind of it will be the same thing already, right? Like
Yeah.
you're interpreting vectors in the model. It's just if your contest starts also being vectors, you can just do
Okay.
that.
Would it be funny if you had like you have like this model that's trained on the gender data and refused to say it, and then this other model that's trained on this like gender data as well. But instead of like giving you the correct answer that it's male, it would be trained to say that that it's a female, like the exact opposite basically. And then you had another thread model that would be like, oh, it's actually instead of saying it's actually lying, it would be saying actually it's saying truth, and so on. And you would have like lying models classifying lying models by lying. Oh my god!
Also, I see Abai when they gave them feedback from him. I haven't seen Abai in a while. He's still a mod in the Discord, but he's not been here since he started working for Anthropic. So.
Who?
Abai is Sandri, like he's here. Like I co-wrote my previous paper with him, but he then went to work on Anthropic, and he used to be on the reading group and like be on one of the mods of the server, but I haven't seen him like since then.
Maybe pinging would bring him back.
I DM'd him once and he didn't answer, but maybe maybe I should ping it on the server someday. I will need. I feels without context, it feels like a thing. Maybe we can. Maybe we can ask him to present one of the Anthropic papers where he's an author.
Yeah.
But there's not enough of an audience for him to care. Or maybe we could get enough people. It's hard to tell.
Anyway, sending dataset tabulations. Another person who also has some papers that could be explained in the reading group but hasn't been here a lot is Wu. Although to be fair, Wood did like post the photo from I don't remember which conference it was recently, but still. Although I was talking in Twitter the other day with one of the authors of another paper that they did recently with Wuhas in HFT camp with Wuhas as the mentor. And they might come to present later the papers in some point in January when they finish because they were expanding on it. And there was I don't remember exactly, but it's a cool thing with the. So I had the idea on that Twitter thread of what happens if you have maybe it would be interesting to look into if you have a transcoder training to a model, and then you have a base model, and you have a transcoder training on a fine-tuned model like an instruct model. It would be interesting to see the difference between those. Do things like take the instruct model and see like how worse the base model transcoder is on the instruct model, and which kind of, if there is some specific latent that it gets wrong, because maybe that's a latent that only exists on the instruct model, but it's represented differently. Mainly I thought that because the Twitter thing was about like the person was getting a bunch of errors, but he said it might be because he's using the base model transcoder on the instruct model because the instruct one wasn't released yet, and that made me think, what happens if you try both and see what the differences are? Anyway, discretional limitations. Attribution articles. Also, we'll see how much of the things we said are already here.
Oh, okay. They also answer another question. Explaining activations from a different model. So they say that someone else demonstrate that activation verbalization models can also interpret activations from different Terrajet models.
Nice.
But they also find that models have privileged access to their own internals, explaining their own computations better than a different model, which I'm not surprised. So they do generalize, but not much.
If that gaps gets bigger on the bigger models, and they get better at like the introspection task and all that.
I would assume it gets smaller, actually. The gap.
I guess that could be that they become smarter and better at that kind of generalization or something. But maybe they get like better at like the bigger models have better access to their own activations or whatever. Like have already some of the things required. If the thing on the is true, the thing on the introspection anthropic paper. Or whatever.
Also, like I would assume like there's also like this, Platonic representation hypothesis with some like a bit of empirical proof in this direction that like the models converge in some way. Different trained models converge.
Reports for many practical problems.
That might also help that.
I might try a bunch of things later with their code since it's open source. I can just ask Claude to make some of my ideas now.
Yeah, just Claude code and my whole Twitter feed is in single written mode about Claude code. It's crazy. I also vibe coded with my research ideas.
I haven't tried. Yeah, I done a bit of that. I haven't tried yet. I need to try using it for my benchmark of can it do the code for the Unity game? Can it make a cool looking structure from code?
And have you tried like games in FreeJS with Claude Code? Like I was like at Christmas family dinner and there's like small kids who had like some idea for a game and I gave it to like Claude Code and it one-shotted it while everything all
nice.
other models failed. So I'm like, what the hell? Okay, interesting.
I have bad memories of that library. What was that? There was three. The
FreeJS.
JavaScript. because
And
my only experience with it is having to fix. Well, I was doing I was an intern with my university for a company that did AI, but I was just fixing the labeling for a leader thing. I was fixing the labeling for a thing, and they use and open some things with use.js and was very broken. So yeah, but yeah, that's
yeah,
nice.
like all the models are trained the most on this library. So if you that means they are the best at coding games in that library. So yeah.
I think that the code from that thing was probably would be better if it was byte coded.
Yeah. Maybe.
I probably shouldn't talk too much about that, but yeah. Yeah. Or very much simplified and narrow. Find tools that modify the base model along a small number of behavioral dimensions. Realistic post-training pipelines introduce richer changes than the single behavior fine-tunes we study. The results therefore show that division one
Okay.
response future work. Yeah.
We just need ultra general model that just is trained on everything. All layers, SAE features, activations, everything. Chain of thoughts.
Yeah, why not? I mean, the
All
thing
the
is harder
progress
to
is
test. The problem is that it becomes harder to test, like how wide it generalizes and how much we should trust it and other things.
Yeah.
But yeah.
Just all modalities in one model. Seems like everyone is shifting towards this pragmatic Mech Interp generally.
Yeah. Although, although we still have some of the problems we talked before of what if your base model is misaligned and that makes the
Yeah.
base model, the activation oracle misaligned. And I feel like we could test. Maybe I can one of these days just, or maybe in February when I finish my current project, I can, maybe my next thing can be testing what happens if a misaligned based model, when you maybe train it with a backdoor or something, with that, what does to an activation oracle? Because that seems interesting. And maybe it does, it does have the problem of if you have the backdoor, the misaligned oracle also sees the backdoor and then it gets, it starts not doing the thing you want. I could see it going either way. They both seem plausible to me. It might also depend on like how long you train on the whether you train with LoRa or something, on how long you train on the activation oracle task, and how that overrides the original model. And that's the kind of thing I also change with size and whatever, and I be very complicated machine learning alchemy. Thing.
Sounds interesting. Could be
this
done.
in general, I think my conclusion for this is a nice thing. I do think it's probably at least done in something slightly interesting where it's just not learning to read the context from the activations, and it can do some other things, but I will want to see. I want to later look at the actual tasks, right, and figure that out. Like the gender, make sure that we are right about the gender thing and all that. But yeah, and I want to see a lot more work on this and all that. But also, again, we're talking about the new thing. I do feel like that this is also another paper from the Owain 7's math stream. Why does it feel like, maybe this is just me finding more about them, but does it feel like a lot of the most interesting papers come from this group, and like feels like there's a lot of obvious interest-based idea that only Owain 7's math students can think, and then the rest of machine learning kind of doesn't for some reason.
Concentration of intelligence.
I guess all of the best people at this kind of more interesting about this kind of thing. Oh yeah, also Clément Dumas is also on the. It's also an author of the paper that I saw it because he mentioned the reading group.
Yeah. So he can also like give a talk about it.
No.
Or something.
Yeah. So. There was a section that I kind of skipped where it was more dataset. Yeah. Personal query.
Also skip that one.
Yeah. Maybe it's interesting. And I guess we can look a bit at that appendices if there is anything interesting we missed there, and then we can end it. It's been 3 hours already, so.
Yeah.
Also, is there anything on chat? No.
Bitter lesson build Mech Interp. That's such a cool name. Oh well. I hate and love it at the same time.
What? You mean the name of the?
Yeah,
Of
that's
the
the fact that we're getting bitter lesson builds like results.
I
Basically.
mean, that's also what the machine learning people.
Yeah, basically, yeah.
But I feel like this is more. Yeah, but still black box interp. Like it's not really making. It's
Yeah.
black box interp, but not black box making interp. It will be really cool if we figure out black box making interp, where you. I don't know what that looks like. Maybe it turns out that just looks like train a sparse model and some bridge like the the OpenAI paper or something.
That seems
In some
whiteboxy.
sense, sparse autoencoders are better lesson built in Interp in some sense.
Yeah. In a way.
We need something like that. But this one doesn't. I guess you could find a way to train a language model to give you some making there like more mechanistic explanation of how the model works, and that you can then validate somehow on the model. I don't know how that looks like. I can see that right now. I have no idea what that looks like, right? And maybe maybe next year or whatever, or a few months, the Owain 7's math students will do a paper like that, and then it will look obvious. But then I'll watch this video and see, okay, yeah, at this point that I have no idea, so it's just obvious in hindsight.
Some automated circuit discovery and that by giant LLM or something.
And maybe there is some very simple way to do it, like just tell the model to give you a graph or something, right?
Yeah.
Something like attribution graph, but I don't know how you evaluate after. But I guess there is something like summarize the modeling in a graph where you can do ablations and it gets.
It has to do automated ablations.
Yeah, the thing is that you have the problem. The reason with this kind of thing doesn't work without some model doing it already is because we don't have transcoders are not good enough. Like current transcoders are not good enough to have features which you can individually ablate and make graph for that, and that have good explanation power because it's not like the correct way to divide the model. And Yeah, otherwise you wouldn't need a fancy thing already. You can just automatically update everything or do a gradient-based approximation like gradient patching or whatever, and use that iteratively to get the correct thing. It will just be a question of compute. But we still don't know how to divide it. But maybe there is something where instead of figuring it out, you can get a language model to figure it out. But I wouldn't know how you evaluate it because you don't have a ground truth of the true interp. I guess you could train it on some model that you hand design, like you do, like for example, you do a tracer thing where you code a model and compile it into a neural network.
Okay, yeah, that you would have to solve like white box model building in the first place.
You can do that, right? Like for very dumb programs, you can handcraft a neural network or like make a program and convert it in a neural network. The problem is that doesn't necessarily get you realistic neural networks, and that be very different
Yeah,
from a
exactly.
real model training with great descent. So that's that's probably not doesn't work.
Maybe
I
there
don't
could be
know.
some way to generalize or something.
Yeah. I expect models don't generalize from the handcrafted ones to the real ones. So yeah, I don't know. You will. I guess you could have. We do have like one or two models where we have them reverse engineered, like the modular addition model. And I don't think actually we don't. Do we even have anything else? Like there is my paper where we reverse engineer a model that did a graph thing, but we didn't even fully reverse engineering as much as the modular addition one. There is still parts of the model where I like, yeah, this just works somehow. Like it gets this thing, it attends to this with some math. I don't know what math. And yeah, I guess I do know how a modular multiplication model works, but only because it does almost the same thing as the modular addition thing, but with an extra step. And I don't know if I might ask Claude later, I don't know if there is a lot of papers that actually fully reverse engineer the model to the point where you can replace the model by with some math, equivalent math, and get the same results even out of distribution.
There's Have you read the toy model of universality paper? It's like 2023.
Yes, but isn't that I guess, but it wasn't that. At least it was a handcrafted data set, which was kind of weird. But I guess they might have reverse engineer. I don't remember.
I haven't read it, just the abstract some time ago, but I really wanna read it. And it's very heavy. Well, not sure how heavy. Like it
I
uses
think
group
we
theory.
maybe read it on the reading group at some point, but I don't. Yeah, it's being it's being a very long AI time. See, more than a year.
Yeah, exactly. It's ancient.
The ancient times of last year, but it wasn't even last year, right?
It's actually almost 3 years old.
Oof, that's
That's
very
ultra ancient.
that's prehistoric already.
That's from Big Bang.
Yeah. Anyway, going back to the paper a bit before we kind of are talking about something else. Let me see if there is
Yeah.
anything interesting in the paper, and we can kind of leave it. I mean, we can talk a bit more about Mech Interp, but I should close the recording for people who are watching it. I don't know if a lot of people watch the recording anyway, but yeah.
Yeah. Well,
Anyway.
maybe. I at least share it sometimes in some other groups.
So yeah, the thing I was saying is before that, yeah, you may be able to train on certain type models that are real models, but we know the answer because we did Mech Interp on them, but we don't even have that many examples. There is probably like a few examples. There is more examples of reverse engineering bits of bigger models instead of fully reverse engineering any model. So yeah, I kind of want to see more people reverse engineer toy models. I know why Neil isn't very interested in that anymore, But I have takes like the modularization seems like it led maybe to people figuring out the spirals thing and all of the helix thing. Seems a lot of it is downstream from the modularization model.
Definitely.
And maybe there is, so maybe it's not as, I feel Neil says something. There was another thing that I disagreed with Neil on the thing, but I didn't actually say that on when I answered Neil on the reading group channel. Maybe I should have, but I didn't have like my ideas pre-ordered out that. We have to need to think more about it. But yeah.
I believe there is some periodic table of circuit shapes and circuit functions.
I feel like, yeah, I feel like no, like I was only of the few people actually trying that at some point, like trying to reverse engineer tiny models. I mostly fail at it, a lot of them that I tried. I kind of did success at the one where I released a paper, but we didn't fully reverse engineer it anyway. Or like not as much as the Neil paper. We just learned a bunch of interesting things about how it moves information and like what attention layers do. But I didn't get the full picture of what the actual layers are doing and how the thing is encoded and whatever, which is probably some geometric thing. But yeah, we didn't figure that out. I think it will maybe be easier now that I have better ideas of what kind of things to look for, especially after the spirals thing paper, where I think, okay, I probably should be looking at some geometric structure, maybe. But yeah. Anyway, kind of getting distracted a bit. I was going to finish the paper. Actually, I wanted to see. So there was this last data set. I guess we can see a bunch of. Okay, so here, persona quay, average accuracy, classification. Persona quay was interesting.
Since addition creates some kind of shapes, I wonder if some more abstract math stuff would create some shapes as well. If you generalize addition to like
category theory.
product.
Oh, actually, there was this. Although Neil is less confident he's right, the paper, but there's this paper where the modular addition thing generalized to other math through because category reasons, theory reasons, where there was a. But I don't know enough. I didn't know enough category theory to understand it. But there was a paper where, yeah, that was about universality, where they found that it generalized to group composition. But I do know that
that's the paper I mentioned, the toy model of universality. That I sent.
Oh yeah, that's the one. Yeah, we actually read it on the reading group at some point already. But
okay.
I had the problem of I don't know enough category theory to understand some of the things. but
there isn't category theory in this paper though, so maybe you mean some other one then.
Oh, maybe it's another one. Maybe I'm mixing it up.
Okay. But group composition, yeah, I would be surprised that uses category theory. But I haven't heard of that. That sounds categorification of group equivalent networks. So it's different.
I'll look at that later. Maybe I can find it. Oh no, I think no, it might be there was this one. I was just thinking about how I didn't know what kind of things are group composition, because I think this paper does mention how Spanner was learned to implement group composition. Yeah.
But like in the geometric deep learning uses group theory to analyze deep learning architectures, and now they generalized it in categorical deep learning. into many different algebraic structures, which is what category theory is basically doing often. And I wouldn't be surprised that you could do the same kind of generalization in this like group theoretic paper. Do like similar step basically.
What?
I think it could like be maybe used to like create this periodic table of possible structures that neural networks can learn. Maybe because category theory is like yeah, a general language for algebraic structures, and that gives everything types in a way. It's a linguistic of mathematics, basically. That's one way to think about it.
Yeah. Also, even the thing I was saying, even if we did have a bunch of examples of toy models, it might not generalize to bigger models. So
yeah, that's another factor. But like, even if you can like say that the space of structures that neural networks can learn, therefore that includes toy models as well. Like,
oh no, I was thinking
yeah.
of training, of the thing of training a model to do automatic interp by having examples of models we actually know how they work.
Right. Yeah. I am. Yeah. That connects to what you said longer time ago now in this convo.
Sorry, you already didn't have it in your context, but I was still thinking about it.
Okay. But it makes sense. Like, use that as a Mech Interp ground truth and maybe somehow use it to generalize to other models somehow.
Yeah.
I have no idea how
The
though.
problem is that we don't even have a data set of toy models. We only have like the
Okay.
Neil one, and maybe there is some other papers out there, but we don't. We basically don't really understand almost any model, which is sad. We
Okay.
kind of seems like people could do that. Like I'm surprised how few people do
Like,
that.
do we even understand, like, okay, yeah, like, even if with the modular edition paper, like, you can, I think you can still, I think there's still stuff to understand, like,
Yeah.
like, the dynamics of why does it self-organize to into this
Yeah, but
place in
as
the
long as
first
you
place.
do at least know, like, fully trained model how it works, that's still.
Yeah,
I feel like we
decomposition
need
into symbolic
orders of
something.
magnitude more people working on Mech Interp.
Yeah.
Like if there were a lot more.
That makes
even if I
there's so many papers. There's too many papers to read everything.
Don't you
Still not
still
enough
like?
though.
There is a lot of people papers in. There's a lot of people working on machine learning, and you just read the more important ones and have people filter by which ones get into which conference and which ones are popular on Twitter or whatever.
Yeah, just so much stuff. Honestly,
Yeah.
I feel like it's a lot. I don't know how big it is compared to before, though. For this one
Well,
year.
it isn't it, I think at least AI papers are growing exponentially, but the exponential for AI papers generally is faster than for Mech Interp, as far as I understand, or at least, yeah, the general understanding.
Also, I think. Just Alex is telling me something on DMs about how, because he was hearing us, we were talking about the video quality, and he thinks he can fix something to make the video better.
Okay.
Nice.
But I'll look into that after the reading group.
That works.
Persona QA. Yeah, I wanted to read what Persona QA is because we got kind of skipping it. Oh, that's interesting because so they this is like they have a name and they train on the name having some characteristics, and then you can just have the prompt be my name is whatever, and the model has to be thinking about those things. So this does really skip the problem we were talking about, the model reading the activations. For sure. The gender one might also, but we are not sure because, well, you'd say it does, but I still not completely convinced. because it sounds really weird. But yeah, activation Oracle state. Although the model does seem to do not worse on the persona query, right? Because it's like only 0 point something. Where it's very accurate at the taboo and classification ones.
You mean not big enough accuracy?
Yeah, this is 0 point something, so it's not. At the same time, I'm just saying that the persona query is worse like than the other ones. Also, actually, something else I want to know before ending the thing is so they have different models, right? And one of them was bigger. So I want to know if the bigger one is better at being an activation oracle. I will guess yes.
They always use the same model to interpret the same model, no?
Yes, but still, I wonder if the bigger model is better at interpreting itself than the other ones.
Okay. I think there are some graphs down there comparing the different models.
Yeah. Okay, here. Here it is already on the Tamu Quen. Wait, why I'm confused? Why this is comparing? Is this?
Okay, comparisons are confusing.
Yeah. Is there any? Is there no graph where it compares a model with a different model directly? Okay, open el kernel eval. 0.3. It's not. At least on
Let's
this
ask
one, it's
Claude.
not. Yeah, ask Claude.
Is there a
At
graph?
least to tell it where the graph is, so we can check it and see that Claude didn't hallucinate it.
Yeah.
Soon we'll just have Claude do a talk for the reading group. Claude plays papers. Imagine giving Claude a VTuber model like Neurosama, but with like the typical Claude thing that people make for memes.
Oh.
But it's like the Claude symbol with a face.
If you go to activation oracle results, page 27 at the very end, I think that's the graph. Let's see if. Okay, there are also like, okay, and Claude says something else. Figure 6 on page 9.
Okay, page 9.
Okay, Claude is right, I think.
Oh yeah, you're right. We were just kind of skip it. But seems like the answer is not that. Seems like the answer is being Claude is better than being an open source model regarding at least for persona query, right?
Yeah.
This might also be like Claude being trained on more. We don't know how big Claude 3.5 Haiku is actually. Maybe it's bigger than 70 billions.
Being Claude is better than being open source model.
That's
wow.
like members of the that remembers with the thing on the Epoch AI post where they did principal component analysis of the data set, and they found that you can divide it into variables, intelligence and cloudiness. Where they call it that because all of the cloud models were high on it. Which made me you were worse at math but better at coding.
Mhm.
or something like that. I don't know. Yeah, so we don't know how big Claude 3.5 Haiku is. I guess I can ask Claude, and maybe it can guess.
I would expect it's around 100. Well, you have Haiku, you have Sonnet. I would expect Sonnet is like 500. Haiku is like 100, and Opus is like 3 trillion or 7, something like that.
Yeah, so the
Oh.
thing is, I don't know if it's bigger than 70 or 70 or yeah.
Yeah, also on the page 29. So I was
You
right
can
as well.
probably guess because from the prices and all that on the API.
Yeah. But this is surprising to me, kinda, that like
Well, actually,
if you
Claude it says it's 20 billion parameters, but I asked for the source and it seems to be just guessing. So yeah, I don't know if you do trust that.
I don't. Yeah. If you go to figure 17, I'm kind of surprised. Or figure 15, actually. On page 28. Like the yes-no knowledge eval.
Hmm.
Oh, okay. It's like, oh, okay. If you have open-ended knowledge eval, that works. But if you change it to yes-no, somehow you get almost
So
random
yeah,
chance.
they all get the same kind of thing. Oh yeah, that why does that happen? It's kind of weird.
Failure to
Okay,
generalize.
that might be the persona vector steering the model to say the thing.
Mm.
So actually,
The
yeah,
brittleness
this is
suggests
interesting.
the yeah. They say a brittleness suggests the personal information may not be robustly represented in the model's activations.
But that's not
Hmm.
kind of that still doesn't say anything, right? That's kind of we don't really know why it happens, right? But
Yeah, might be the steering.
but an hypothesis I have here is just it's steering the activation is steering the model because it's the same model. And you could see again if you train a different model and it does better here. Right? If you train Quern on Gemma, Quern on Gemma, then if it has higher or the same accuracy,
I
it
would
will
expect
have
lower a bit,
less.
yeah.
There is a problem. It will do less because they generally do worse because they don't have access to they whether on their own activations, but still. Although I wonder how much of they do better on the same activations is some are stealing effects.
Mm.
But yeah. Like, I guess that the stealing effects will show up as differences in how, like, asking the question, whether you ask it more directly or not, say the thing, that make it you more likely. For example, you could ask. Well, yeah, I don't know.
Hmm. They also compare the different data sets down there. The geometry of truth dataset. Or what is that? Emergent line restriction language. Oh, of true false datasets. The geometry of truth. Interesting. Of course, it's by Max Tegmark with that name. I'm not surprised.
Yeah, the Maximum has a lot of cool papers.
Yes.
Like, I mean, I know
Geometry of
people.
truth sounds so divine.
People,
Yeah.
I feel like people like Neil kind of gave up on the whole look at things in small models and try to relate to big models. But at the same time, I don't think it has really been tried. Like maybe it's not the best thing for people to use our time on, if like with
But-
limited
Mhm.
people and all that. But still,
Why is no one looking at the bigger models? At least in the open side. Well, I guess in the big labs they are, but like
people are looking at it's kind of harder, but also I feel like people are doing a lot more trying to understand big models, which makes sense because it's more interesting. But I would want to see I don't know, I would want to see some random students like that want to do some Mech Interp. They could try to reverse engineer a tiny model like Neil did.
mhm.
Like on the modular addition
Yeah.
paper. And maybe that would be interesting because we don't have basically any model that people have reverse engineer. Like it would be a thing if people have wasted a bunch of their time doing that and they never did that. But I don't think that's really true, right? I feel like that not a lot of people have done it. Like I think if it was happening was at the start on Neil applications, but at some point Neil said on the applications that he was not interested in that kind of thing anymore, and people stopped doing that.
Was he not interested in?
Oh, the toy models, reverse engineering toy models.
Yeah.
But didn't just feel, but basically nobody has done it anyway. Like I feel like at some point I was talking with Narming about this, and I feel like Narming basically thought that basically it was mostly me at some point when I was doing my previous paper, and we didn't end that completely figuring out how that model works. Which I mean, it's maybe another reason that we spent a lot of time trying to reverse engineer a model and we didn't even like completely understand it, right? So and it was pretty hard, but also didn't require any special knowledge or anything, right? It was just spending a lot of time looking at activation patterns and thinking very hard and running a lot of patching and a lot of things like that manually. Yeah.
Hmm.
But I wish we were in a world where this Mech Interp is widely more popular even than this today, and like I don't know, students in university are doing this as part of their class projects or something, like reverse engineering tiny networks or something.
Well, so
I
some
guess.
uni I linked started having classes on Mech Interp.
Oh, actually, maybe I just need to wait a bit and have Cloud Opus do it. Maybe
Yeah.
it can already do it. I actually was trying to reverse engineer a tiny model the other day because for my current research, like I was kind of giving up on that. I was doing doing research on a bigger model now. But I like just tried using Opus on the old version.
This
And
was
kind
your
of was
Neil?
doing better than me. Oh no, that's
Ugh.
just my current research stuff.
Ah.
The one I got a grant for.
The Neil
And
apps are always so competitive, but like also for research. Are you trying to are you done with it already, or you're still working on that for your grant? Is that the grant paper you're
I am
talking
still
about?
working on it. I land in February. But I'm thinking that
Um,
for tiny models, maybe. Also, I think we are not talking about the paper anymore. Maybe we should just stop the recording all that because that's
Yeah.
way too long.
It's too long. Just end it now. Oh yeah, is your I remember the My Little Pony avatar.
Hmm.
What was his name again? Shoot, I
Okay.
forgot. Yeah, no, Alex is still here in the background, right? Or because I heard how you talked about how he said he'd fix the recording.
Oh yeah, but he just listened to the start of the video.
Okay,
But yeah.
he was like I was like thinking like is he like listening through you?
Oh no. He was just listening on YouTube. He doesn't live here. Well, I mean, he lives on the same city, but not like.